We assess their relevance for data protection, and we inform the work of the EDPS on all technological aspects. And in that context, as most of you know, since 2014, in our IPEN workshops, we bring together privacy experts and engineers from public authorities, industry, academia, and civil society to discuss relevant challenges and developments for the technological implementation of data protection and privacy. The focus now is how to make personal data protection work in practice. Before we start with the webinar, I would like to thank TU Delft for hosting us on their Big Blue Button online learning platform. And some necessary house rules for today's webinar. To save bandwidth and to make the experience smoother for everyone, can I ask all participants to switch off your audio feed, your video feed, and mute your audio. If you have technical issues, which cross fingers you shouldn't have, but if you do have, then please alert our tech support by going to the participants list on the left in your browser, and then you can click on the user 001 technical assistant, so 001 with a license to help. And then you can send our tech support a private chat message and describe the issue. And please do not use the public chat, the general chat, for your technical issues. If you cannot connect at all, please send an email to ipen@edps.europa.eu. During the webinar, if you have questions, please put them in the public chat function, and then we will try to answer them during the Q&A sessions. Again, please use the public chat for your questions on substance. If you have technical issues, please use the 001 technical assistant exclusively. The workshop will be recorded. Only speakers and moderators should use their camera and microphone. And if you don't wish to be recorded, then, as I said, please simply mute your audio and disable your video feed. We will not record during the bio break later on. So let's get to the substance of things. Our online IPEN webinar today will focus on the use of synthetic data as a possible technology to mitigate data protection risks. Synthetic data are not real-life data, but they are created from the real ones in a way that they can still be useful in context. So in the current debate on the use and policing and regulation of artificial intelligence in the EU, in the US, and elsewhere, the offer of synthetic data as a privacy-enhancing technology has dramatically risen. So the aim of today's workshop is to explore the possible use cases, relevant limitations, and to raise awareness and maybe see how to better frame the potential of this technology. I'm very proud we have a stellar lineup of speakers today. We, of course, begin, as is tradition, with a keynote from the European Data Protection Supervisor, Wojciech Wiewiórowski. Then we have two sessions. First session is from the practitioner's perspective, with 4 speakers from 2 different continents, with a coffee break in between around 2:45. Then the second session will look closely at the legal issues of synthetic data. My EDPS colleagues Massimo Attoresi and Anna Kollaps will moderate, introduce the speakers of their session, and take your questions. And also, as is tradition, at the end we have a networking possibility. This room will stay open, and we can get to know each other in that room. So, with further ado, I wish us all a great discussion. And I'd like to give the screen to the European Data Protection Supervisor, Mr. Wojciech Wiewiórowski. He was appointed by a joint decision of the European Parliament and the Council on the 5th December 2019 for a term of 5 years. Wojciech, the screen is yours. Welcome.
Thank you very much. I'm really happy to open the next meeting of the IPEN, the IPEN workshop that we organize already for some years, and where we try to get a little bit closer to the practice and also to influence our normal activity with the point of view of the engineering society, of those who are actually probably more responsible at the moment for what we do with the data and how the data is protected, than those who are responsible for the business models or for the legal background of the things we do. So, ladies and gentlemen, welcome to our traditional appointment with the IPEN annual workshop, which takes again the shape of the online event. Well, I'm looking for the possibility and I'm looking for the next occasion to meet you in the real world and to be able to talk with all of you in the same room. But of course, meeting in the online platforms have some pros as well, and these pros are that some of you can stay at the place where you are normally, where you work normally, or to take part in the other event at the same time, or to go to the wonderful island and to spend the time there, but still have a possibility to take part in something which is interesting from the professional point of view. By the way, Brussels is really reminding today the best places to spend the holidays in, at least as far as the weather is concerned, probably not as the city itself and the smog is concerned, but if you think about the weather, it's really more than 30 degrees as it is generally in the western part of Europe at the moment. Let me refer for a few minutes to the steps that lead to creation of something original as an artistic piece. Regardless of the form of the artistic expression, the process seems to follow more or less the same path. I'm a big fan of music, but I don't play any instrument. I'm definitely not an artist as far as music is concerned, but I'm observing right now two persons in my family, my daughters, who are recognizing the strength of art, mainly through the music. Well, first in music, the first steps, the first stage of involvement in the learning of music is, of course, the practicing, the learning the notes, learning the tempo, scales, tonality, learning the atonality or the use of the instrument itself. Not necessarily the theoretical things, but also the practical one. This progress requires the individual to process a high volume of information and may take hours, may take weeks, may take even years. Once the individual have begun to understand the artistic piece, they can start to execute and reproduce the piece. Both in the process of understanding the art and the process of knowing how to reproduce the art will greatly improve if artists would get and correlate in influences from several sources, from different persons, the peer executants, all the way leading to making the artist more complete. And eventually, the first stage, the third stage, the artists will be able to create their own original music, their own original pieces, while bearing in mind that recreating the previous works would result in plagiarism or tribute. Sometimes it's difficult to draw the line between the variation on something and the tribute and the plagiarism. And the artist should use the gathered knowledge to produce the relatable yet still different piece of music. Each artist would produce multiple original pieces, all different one from each other, and while sharing the structural similarities, that will allow the public to recognize that the artist has its own style, and or her own style, and possibly some of the artist's influences can be recognized, and this process is not that much different from the process used by the artificial intelligence to create the synthetic data, which we are going to talk about today. The process of so-called data synthesis would take observed data, the training data set, and capture its variances in the model. From this model, it would generate the new artificial machine-made data with statistical properties similar to the original ones. And keeping the statistical properties means that anyone who analyzes the synthetic data, the data analysts, for example, should be able to draw the same statistical conclusions from the analysis of the given data sets of synthetic data as they would if they given the original data. Although there are several techniques to produce the synthetic data, which we'll be talking about today as well, our event today will be focusing on those models that are based on artificial intelligence, which are the ones best fitted to deal with the complexity of the data. In AI-based technologies, the volume of the data set is much relevant, and the bigger the volume is, the more information will be possible to correlate, still remembering about the minimization principle. And the more diversity is provided during the learning process, during the learning stage of this process, the more accurate will be the system perception of the environment around. And synthetic data is increasingly being used for the machine learning applications. For example, a model could be trained on the synthetically generated data set with the purpose of transfer learning. And transfer learning would allow for storing the knowledge gained while solving one problem and applying it to the different, to the related one. And for instance, the knowledge which is gained while learning to recognize the cars can be used to recognize the trucks with all the limitations that may exist. And moreover, we can observe the increasing use of the synthetic data to test and to train the systems for fraud and intrusion detection, or in the research field to aid creating the baseline for the future studies and for testing. When organizations want to avoid using personal data to mitigate the privacy risks, that's also the place where the synthetic data starts to be more and more popular. And it comes, therefore, with no surprise that the synthetic data is presented sometimes as a kind of a magical solution, almost a panacea in some cases for the researchers and for the practitioners. And it is often boldly claimed that the synthetic data is not the real data. The underlying rationale for that is that synthetic data is the product of artificial processes and not related to the individuals, therefore falling outside the scope of the General Data Protection Regulation. However, this is not completely clear and not quite specific. Thus, maybe real data stands for the truthful data. And the real data is not a specific notion under the GDPR, which rather discerns the data between the personal and non-personal data, though the second notion does not exist per se in the text. And the key challenge in the synthetic data is whether there is a possible way to establish the correlation between the generated data, the generated data set, and the original training data set that could lead to the identification, or I would rather say re-identification, or singling out at least of the real life data subjects. Let me give you the concrete example. Looking at the website that most of you use, this person doesn't exist.com, it shows the particular use of the generative models to produce the new data. The system combines the pieces from the several different pictures of different faces to produce the photograph of the non-existing person. And a legitimate question would be how the result would look like if the algorithm used the pictures of the famous individuals in the training datasets. Wouldn't certain facial features be immediately recognizable in that case? Well, everybody can find how the lips of the singer from Aerosmith look like, and even recognize them and exchange them from Mick Jagger, who theoretically is very similar to Taylor. And these other applications of synthetic data lead us to the key pivotal question here: is the synthetic data anonymous? Is it an anonymous data in the meaning that we can derive from the GDPR? There is a heavy interest these days in synthetic data, and not without justification. If synthetic data proves to be truly anonymous, meaning that the information either does not relate to the identified or identifiable person, or was rendered anonymous, and in such manner that the data subject is not or no longer identifiable, then we are outside the scope of the application of the personal data protection framework, which for many users may be at least useful, if not pivotal. But if, on contrary, it's not proven that synthetic data is a proper anonymous data, then how to qualify it under the data protection framework, and how to make it to fit with it? Is it personal data, non-personal data, pseudonymous data, which is still personal data? What then it is? But how to tackle the risk of the misuse, if there's any? Answer to those questions are unclear and still disputed, and I expect and somehow I hope that today's discussion made better off some aspects of our understanding of the subject. Let me get back to this initial metaphor which I used, the metaphor of artistic piece, artistic work. While in music and art, and the correlation with the prior work of the influencers, and the influences would still be possible and mostly probably natural, the same circumstance in synthetic data and direct reference to prior input would, as a matter of fact, imply that the presence of the personal data defining, or rather defeating the benefits which are heralded and promised by the use of the technology. No personal data should result from the data synthesis. Otherwise, the risk may be that the synthetic data may be the privacy mirrors. And some academics put it this way, because there is no privacy gains in the end of such a process. And quite specific challenge is the possibility of integrating features from records that stand out within the original data set into the synthetic data known as the data protection, by the data protection as outliers. In extreme cases, this would lead to the interference of the data subject. And therefore, the similarity to what is done with anonymization, the process of the synthesis should consider a previous preparation of the data set, and after the model is generated, a privacy assurance assessment should be made to ensure that no data from the data set comes out of the synthesis data. Society can greatly benefit from artificial intelligence, but it is not the technological silver bullet, and new uses and the new the uses as the synthetic data should be carefully assessed, should be carefully used and accessed as well. Accuracy and reliability of the interferences are then other aspects to be considered, along with the risk of perpetuating bias, which may be inherited by the synthetic data technology as well. And let me summarize that, saying that of course the development and the improvement of the services and the products worldwide is demanding, and demands also the steadily increasing amount of data. In most of cases, that will be the personal data, or at least the data that with some additional quantum of information can become the personal data again. And the ability to generate, to virtually, endlessly, the endless quantities of information that reassemble the personal data seems to be very appealing. And the European Data Protection Supervisor has been closely following the developments of the artificial intelligence, and I invite all of you to follow our work, in particular by referring to our opinion on the European Commission white paper on artificial intelligence. But I would also like to inform you that in the nearest days, most probably, the joint opinion of the European Data Protection Board and the European Data Protection Supervisor on the Artificial Intelligence Act will be produced and will be published, and it will also refer to these points. So thank you very much for being with us today, and to take part in the discussion that we are going to start right now. I will stay with you as well, trying to find out what are all the external views and all the internal impressions as far as the use of these solutions is concerned. Massimo, back to you, and I think that we can say that the workshop is open.
So, thank you, Wojciech. Thank you for this extensive keynote. My name is Massimo Attoresi, as Thomas said. I'm the deputy head of the Privacy and Technology Unit. First of all, let me first greet all the old and the new IPEN friends and colleagues, including Akim, who used to be with us in the cockpit. And now I go immediately to the introduction of the speakers of this panel session of practitioners. So I have the pleasure, first of all, and I invite him to come to the stage, to introduce Stephen Bamford. So Stephen Bamford is head of clinical data standards and transparency at the Janssen Pharmaceutical Companies of Johnson & Johnson. He has an extensive experience in the strategic development and delivery of the industry innovations, as well as training pharmaceutical programmers. He has been a member of the Janssen team since 2016 and has helped to implement and support a number of data sharing initiatives during this time. He has over 25 years of experience in the management of clinical trials and research data with pharmaceutical, life science, and research organizations. So, Stephen, we are very happy you are with us. The floor is yours.
Thank you very much, Massimo, and I am very humbled to be invited here today in such a prestigious audience of people. So thank you for inviting me today. Before I start, I'd just like to say the opinions I'm going to talk about today are my own, and they do not necessarily reflect all the policies of J&J or Janssen Pharmaceutical. So just very, very briefly, I've been working in healthcare since the mid-1990s. I'm currently the head of data standards and data transparency at Janssen, where I've been doing that now for 5 years. But alongside my professional career, I also founded the FUSE organization, which is for data scientists and programmers within the pharmaceutical, the healthcare industry. And I'm just calling that out that they've got a very, very active data transparency group, which does look at things like synthetic data, and it's really through my experiences, both in my day job and through FUSE, that today I can update you with what we're doing at J&J, and more importantly, the journey on how we got there. So today I've got about 20 minutes. Hopefully I'll keep you awake for 20 minutes. I'm going to talk about the background of data sharing. I'm then going to give a very, very brief overview of the privacy-enhancing technologies that we use, but very, very quickly drill into the synthetic data PET, and then I'm going to explain what we do so far, where we've come in the last 18 months, but I'm just going to close then on some thoughts around the future of synthetic data. So hopefully you're all at the right event, and this is what you're expecting to hear. So the background to data sharing within healthcare. So there's three things that we need to do. We need to look at the external environment. We need to look at the regulatory frameworks that we need to operate in. But also, we also have a responsibility to share data in an ethical way. And it's the balance of these three different piers that basically lead us to the work that we do when sharing data. Now, I could spend about 40 minutes on this slide. The slides will be shared later. Anyone can reach out data if they want more details. But essentially, we're being pulled in many different ways. We have collaborations that we take part of, whether it's cross-industry things like Transcelerate, whether it's European IMI initiatives, whether it's oncology-based Project DataSphere, the collaboration for sharing data, and since COVID, this has become even more of a growing area. Many registries within the world. Last time we counted, there were over 160. That requires changes to data. There's a big change coming up as of probably January next year with UJCT moving to the EU CTR, and then you've got the clinicaltrials.gov based in America. In the last 5 years, you've heard journals and publications. They've been asking people to share data. You've then got researchers, whether it's Bioethics International doing the Good Pharma Scorecard, it's Ben Goldacre in Oxford doing his All Trials Network. These are publications that call healthcare industry to account, really, to share data openly, and that's really the premise of what we're trying to do: share data in a secure and privacy enhancing way. The regulatory agencies, there are different approaches by global regulatory agencies. It's great to see alignment between the EMA and Health Canada, with the EMA Policy 70 and the Health Canada PRCI about sharing data once products have been approved. And then we do a lot of research with data sharing. There are platforms like the Yoda project that J&J uses. There's Vivly that we also use that more companies are on. And these are really different ways that we can share data. It hasn't always been like this, and it's changed over the time. 2005, I think it's fair to say that data used to go into a big warehouse and never saw the light of day again. but by 2015, it probably went too far the other way, and there was lots of sharing between companies and both within and outside companies, and it probably went too far from a privacy point of view. And now, whether it's 2020 or 2021, we find ourselves having to control privacy, legal, and ethical considerations, and balance the equation between the want to share data, but also the responsibilities that fall upon data holders like pharmaceutical companies. So I'm going to just briefly talk about some privacy enhancing technologies, just to frame how we got to where we are today. And the data that we have, like the raw data, we call that key-coded data. And then essentially we have two different types of anonymized data. We basically have the risk-based de-identification. That's essentially the gold standard. It's what's quoted in the working party documents. It's what's quoted in the regulations and the policies, and that's essentially where you get down to a residual risk of 0.09, and that's really where basically people expect the data to no longer have a privacy concern. For internal use only, where there's greater controls in computer systems and processes and the whole control around the data and the data handling, we do have a version that we call GDPR anonymization that has slightly higher data utility, but because of the controls, it balances the risk. But about 2 years ago, we thought that we could do with another privacy enhancing technology, and that's really where we embarked on clinical data synthesis. And as you heard in the opening keynote, this is where we create a synthetic model to generate artificial, realistic synthetic data. Now, when you look at what we do, we have to balance the risk and the data utility. And the GDPR anonymization, as I mentioned, is for internal purposes only. The risk-based de-identification is where we share the anonymized data for research purposes. But the data synthesis, one of the benefits that we see that bringing us is that it's not considered personal information, because the data isn't actually linked to individuals. Now, you're going to hear later on today about the process of how you create synthetic data. So I'm not going to go into that so much today. I'm just going to talk about how we actually practically use it. Now, this slide is again very, very detailed. I could spend 20 minutes on this one slide, but basically what I just want to call out here is these are the types of things that we look at. We look at the governance structures we got in place. We look at the privacy risk. We look at data utility, where we have to adhere to the primary use of the data, and we also try and put data minimization techniques in place wherever possible. Now, as you move across the slide, what you'll see is the key-coded data in the middle there. That's our raw data, if you remember me saying. And then as you move down through, you see that if we just take the privacy risk, for example, the privacy risk is very high with key-coded data because that's our raw data. By the time we put the GDPR anonymization approach on it, it becomes down to medium. When we get down to the risk-based de-identification, we classify it as low. And then clinical data synthesis, we classify it as very low. And likewise, if you look at the governance structures in place, unsurprisingly, when you actually follow that trend also follows with the governance. But again, I want to get onto the main bit of synthetic data, so I'll march on to the next slide, which shows how we actually use this data. Again, it's the structure of the slide's the same way. If you look down that middle column, key-coded data, you'll see that the only time that outside of the reason why the data was collected in the first place, of course, the only place that we will use the key-coded data is for primary reuse of the data. Apart from that, we have a number of categories here. So you can see that, for example, software testing, internal and external, there are differences depending on the footnotes that you'll see here. That basically drives the fact that internally, for doing software testing internally, we have more control again. And it comes back to this balance again of risk versus data utility. But synthetic data, you can see here, can be used for all 5 of these categories, whether it's internal, external, software testing, or secondary research, or primary reuse. And that's really where we've ended up today. So when we get a research request come in, research requests come in to us every day, sometimes multiple times a day. We look to see whether or not the research proposal is in scope of primary research. If it is, they can use the key-coded data, but of course we look to address data minimization principles. We check the IT security requirements. Usually that's not so much of an issue because it's only within the internal firewall of the company. But the first thing we then ask them is, can you do your research using synthetic data? And if they can, that's great. We then give them the synthetic data and they go on their merry way. If they can't use synthetic data for whatever purposes, we then move down the flow chart here to using anonymized data. So this is where it sits within our privacy enhancing technology stack. So what I'm going to do, I'm going to focus, because time's marching on, I'm going to focus on the synthetic data within Janssen here and where we actually find ourselves. So around towards the end of 2019, so essentially the first half of 2020, that's when people still went on planes, if you remember those days. We were evaluating the synthetic data. We were getting feedback from internal teams about the value of synthetic data and how it can be used. And then that moved us on to the second half of last year, where basically we essentially did a strengths, weaknesses, opportunities, threats analysis. We basically went out to different teams who started to use the synthetic data, and we asked them to report on their experiences of essentially the strengths and the weaknesses. And then feedback from these teams were then used to iterate on the synthetic, or rather the synthesis specifications that we then use. As I speak to you now, as we march towards the end of the first half of 2021, and I still haven't been on a plane, we're basically into the production and scaling. So we're trying to automate synthetic technology a lot more to meet very, very tight service level that we actually have with the project teams. So that's basically where we find ourselves at the moment. And it would be amiss of me not to mention that, that at this point we actually have 33 clinical trials, complete clinical trials that have actually been through the clinical data synthesis process. So I quite often get asked what the differences are between synthesis and anonymization, and there's details in the slides that you'll see later on. But basically, the key points really are that we see it as there's less disclosure risks for the synthetic data rather than the disclosure risk for anonymization. So therefore, we need fewer controls. So it's easier for us to process internally and quicker for us to process internally, and we are finding now that the process can be a lot more automated, and again that comes back to speed, being able to give synthetic data back to the project teams a lot quicker. But I guess if I was to take a step back and sort of look at it. There are attacks on anonymized data, and that does worry people, especially in an industry which is actually quite conservative in nature. So anything that we can do to mitigate that definitely helps us, and that's really where we find ourselves today. So there are plenty of use cases, but of course we're new on the journey. We've only been doing this now for probably just over 12 months, really, by the time we actually got up and running. So we don't use synthetic data for all of these cases, but we do use them now for 4 cases, really. Now, some of the first cases that we used was for software testing, and then we then moved into using the synthetic data when doing internal education or internal training courses, because we didn't want to reuse a patient's raw data for somebody to train on. So that's really where we started off with use cases in software testing and education training. And then more recently, we've actually gone through a request for proposal, and we actually were able to create synthetic data and actually set up a computer environment and invite companies in to demo their software using the synthetic data. We would have never done that using real data before, and the hurdle of using anonymized data was just too high. But the legal opinion that we had was to use synthetic data was actually acceptable in this situation, because there were the entity was known to us, and that there were NDAs or CDAs in place as well. We have actually now moved on to data exploration, and some of the project teams have been so impressed with the quality of the synthetic data, and essentially they've rerun the original analyses of the study using the synthetic data, and were amazed about how similar the results came out. These teams are starting to basically use data exploration, but it is a journey, and we are starting up speed internally, but we do realize that everyone moves at different spaces. So we do get a number of questions from the project teams. So is the data utility good enough? Well, yes, it is. And we basically look to see that it's about 95 to 97% accuracy compared to the real data. And of course, we can't get much more. We can't train the model much more than that. Otherwise, the privacy concerns would come into play. And we find that the risk of dealing with synthetic data is lower than that of anonymized clinical trial data. So the project teams are equally happy with that, especially when they see the data quality. We are having conversations with privacy regulators and with drug regulators from time to time, and we are moving slowly into those spaces. But of course, it's new for everybody, and we don't expect anybody to take unnecessary risk. And we like people to evaluate the data like we've been doing for the last 18 months. So I'm going to talk about the my thoughts around the future of synthetic data, because I'm fast approaching the last couple of minutes of my presentation, and basically I thought I would start off by talking about the acceptance of synthetic data, first of all within Janssen, and the more examples of uses that produce value to the organization, the more data users are starting to become comfortable with basically using synthetic data. And as data users see access to synthetic data is easier, it's quicker, they're becoming more willing to move in that direction. The less friction they encounter to get the data that they need, the more interested they are to adopt the data. But we haven't yet moved fully into simulators. We've started talking about getting simulators, and they could have an input on the adoption, because they could make data access and data use even easier. But we keep getting the messaging from internally about what's the regulatory perspectives, because these will be very important for the internal adoption as well. And given the landscape around what's deemed acceptable anonymization and non-identifiable data, it's really complex, and clarity on synthetic data would really have an important impact on the adoption. So unsurprisingly, I guess businesses and users in general don't like uncertainty. So if the regulators could come and set some parameters around when synthetic data is usable, then that would also help with adoption. 2 slides to go. So when I move outside of Janssen, and I think more broadly around the life sciences industry, so more broadly, different companies move at different rates in terms of adoption of new technologies. But it's fair to say that many life sciences companies are investing heavily in artificial intelligence and machine learning, and are reusing their existing data to drive innovation like this. This means that the more we can do to reduce friction to access the data will be important, and the technologies that enable this will become more prominent over time, I believe. So my closing slide, I believe, I'm going to end with a call to action. I'm going to call to action really to the privacy community and to regulators to help develop clear guidance and frameworks for evaluating privacy risk in synthetic data. It would be really, really helpful to reduce uncertainty. It would make it easier for companies to adopt the increased uses of synthetic data like we're doing here at Janssen. And in a short time frame, we've accumulated data and expertise, and we've been able to produce guidelines and frameworks internally. And the technology, I guess, is moving rapidly from being early stage to being more mainstream, and again, that's going to help adoption. But this would be an ideal time really to put together a guidance and a framework to help shape that transition. And that is all I was going to say today, and hopefully I've managed to keep to the time.
You did it. Thank you so much, Stephen. We were a bit late already when you started, so that's not a problem. We have, two questions from the public. I also had another one. Let's see whether we can go very quickly on these questions, really with a quick reply. I just read. Does use of synthetic data extend to medical image data? Meaning, is it possible to use synthetic medical imager for software testing? So this is one question. I don't know whether you want to reply immediately to that very quickly, and we go to the next ones.
Very quickly, we haven't been able to use synthetic data internally yet for medical images. We do have a process that enables us to share medical images, but that doesn't use synthetic data at the moment.
Okay, there is another question on the idea of whether it is possible to generate synthetic data for relational database where the relations are not related to user identities. I don't know whether I understand correctly the question, but I leave it to you. Otherwise, we go on.
I will look into that, and I'll read that again afterwards.
Yeah, okay.
And get back to you.
We'll share that. Are you evaluating Janssen? To participate within, Gaia X project, meaning as a data provider and as contributors to protocols and methodologies that would allow the safe and compliant sharing of data. Gaia X, this initiative for a European valued cloud. Don't know if you're aware about that.
Yeah, we do share data wherever possible, and basically we have a process to follow depending on the needs. So I can't imagine that somebody within Janssen isn't already linked into that project.
Okay, and then there is another question that says, how well is it, that's quite in-depth, how well is it possible to synthesize data with time series, meaning with evolving, for example, symptoms for each patient?
Yeah, this is what's taken the time. We can do this type of thing now. It's basically taken us a while. And that's why the project's taken 12 to 18 months. Healthcare data is actually, as you are more than aware, is actually quite complex with the relationships both over time and the within subject relationships, and that's something that we've actually been working really hard on.
And I have a last question for you. It's from my side, and then we pass to the next speaker. I'm very interested in the use of synthetic data for testing purposes, because, we have a lot of SMEs, public administration that says, we need to use real data when they are personal data. We are talking, of course, testing with personal data when you have, this personal data within the system. So do you think that this is feasible for SMEs, for public administration with limited budget? Does this need a high level of competence in-house? Is something that everybody can afford? Do you think there is awareness about this opportunity? What do you think?
I think it's one of the most cost-effective privacy-enhancing technologies that is available. There are coaching sessions out there. There's basically a lot of material that's already available. I'm not here to plug the Fuse organization at all, but there has been like open access training courses on how to create synthetic data through that platform. So people were very hesitant to begin with because they have this desire, they have this we need the real data, they need that all the time. But the head of statistics at J&J said himself that 95% of the work they do could be done on synthetic data, and that really struck a note with me. The fact that people just need to move their mindset.
Okay, thank you very much, Stephen. We have also other questions, but we will use them also for next speaker, who I'm going to introduce. And I thank you so much for joining us. So, next speaker is Professor Khaled El-Emam, whom I invite you to come to the stage. So, Dr. Khaled El-Emam is a professor in the School of Epidemiology and Public Health at the University of Ottawa, and a serious scientist at the Children's Hospital of Eastern Ontario Research Institute, where he's a director of the multidisciplinary Electronic Health Information Laboratory. His lab conducts research on privacy-enhancing technologies to enable the sharing of health data for secondary purposes, including synthetic data generation and de-identification methods. Professor El-Emam is also a co-founder and director at Replica Analytics, a company that develops data synthesis technology. Yesterday, last but not the least, Professor El-Emam was awarded the Canada Research Chair in Medical Artificial Intelligence to focus on developing a methodology for the synthesis of complex health data. So thank you so much for coming with us, and I give you the floor.
Okay, excellent. Thank you very much. And thank you for inviting me today. The objective for me in this presentation is I'll provide you a general overview of synthetic data generation and its applications. This will be an applied perspective on synthetic data, given the broad audience that we have today. In the slide deck that you have available, there are some references at the end to some of our work if you'd like to take a deeper dive into the methodology and algorithms and some of the points and examples that I will present. My focus will be obviously heavy on the privacy risks from synthetic data and methods for evaluating those risks, but I'll also try to provide you with a general perspective on the topic beyond privacy, since multiple factors need to be considered when we are talking about any privacy-enhancing technologies, and I think the previous presenter touched upon those as well. So in terms of the agenda, I have three general sections. And for just maybe as a preamble, I mean, there's the academic hat that I put on, but also there's the applied hat, since we've been developing synthetic data generation technology and deploying them in practice. So there's also a very practical and applied bent to some of the points that I will be making. So I'll first give you an introduction to data synthesis in the context of producing non-identifiable information. Then I'll explain the privacy risks from synthetic data and what they are, as well as demonstrate the utility of synthetic data. And then in the third section, I'll provide an overview of some of the common methods for the generation of synthetic data. So I'll try to cover all the I think that the topics that are of interest to this audience. So let's start off with explaining some of the uses of synthetic data. Again, these were already touched upon, so I'll be brief. The whole topic of data synthesis is relatively recent, at least in the mainstream, so it's helpful to get a sense of where these can be applied. The basic premise is that synthetic data is non-identifiable data or non-identifiable information. It's not personal information. But beyond that, synthetic data has a number of significant advantages over other approaches for creating non-identifiable data. I'll discuss those later on. Data synthesis is applicable across multiple sectors. We've applied data synthesis for health and financial data, but of course, there's no reason why this cannot be applied in other sectors such as telco, retail, and automotive as well, just to name a few. So one primary use of synthetic data is to enable data sharing and data access because it's not considered personal information. I'll discuss that point in more detail. So I know that requires some unpacking. But because it's considered non-personal information, it can be used and disclosed with minimal constraints. We also see many organizations that are investing in data science and AI capabilities. but there is friction for their internal teams to get access to that data for their analysis, and synthetic data can solve that problem quite easily. And the AI models built using the synthetic data will be quite similar in performance to the models built from the real data. Software testing is another common use case, either for internal business or when building commercial products. Production data is still very frequently used, and we need to move away from that to enable organizations to create synthetic data for their software testing requirements. Beyond data sharing and data access, synthetic data can be used to amplify small data sets. This is helpful because many of the modern AI and machine learning analysis methods require very large data sets, and sometimes organizations do not have access to very large data sets. Synthetic data generation methods can help create larger data sets that retain the patterns in the original data. So essentially a data amplification scenario. The same approaches can be used to correct biases or imbalances in data sets as well, by creating new synthetic data sets without these biases in them. There are a few more profound applications of synthetic data, especially in the healthcare space in terms of data augmentation. But for today, we'll just focus on the applications that are related to data synthesis being a privacy-enhancing technology. So let's talk about the data synthesis process, just to set a foundation for everyone and look at how it's generated. So there are many ways to generate synthetic data, but essentially you start from a real data set, a source data set, and you fit a model from that real data, and then you sample from that model to generate synthetic data. The real data would be the originally personally identifiable data sets that are available, for example, health records, financial transactional data, or sales data. This is the data that we want to create non-identifiable versions of. Then we take that data and build a model which captures the statistical properties and the patterns in that data. This is typically a machine learning model that's built. You can use statistical machine learning methods or deep learning methods. These types of models have become quite good at capturing the subtle patterns in complex data sets. These models are also called generative models or data simulators. So these are these models that are built here. Once a model is built, we can then use that model to generate new data. This is the synthetic data. So the new data that is generated actually comes from the model that was fitted. There will not be a one-to-one mapping between the synthetic records that are generated and the records in the source data. This is why synthetic data can be quite protective against identity disclosure. You've probably seen synthetic data in the context of deepfakes. So these images are actually from the website that was mentioned earlier in the keynote. This person is not real. So all of these pictures are fake. They were generated from Gans from that website. And you know, I've been tracking this for the last couple of years, and the quality of these images has been improving quite a bit over time as well. So the same principles can be applied to structured data. Here we have examples of images, but you can apply it to structured data, which is a type of data that's shown on the bottom right-hand side of the slide. So this particular data set is just an example of data set that you would see, for example, in a clinical trial. That's really my main focus, is the synthesis of this type of structured data. So you want to generate then new records that look realistic, but in the context of data sets that include personal information, we're also interested in preserving the privacy of the individuals in that original source data. So the synthetic data generation process needs to balance preserving privacy with generating high utility data that looks realistic. So a common question about data synthesis is whether you need to know how the data will be used in advance. This means, is the data synthesis specific to the types of analysis that will be performed on the eventual synthetic data set? The general answer is no. The basic idea is that the data synthesis process is capturing many or almost all of the patterns in the data that the synthetic data can be used in arbitrary ways. Of course, there are limitations to that. For example, very rare events may not be captured well in the generative models, and this is one of the elements that are kind of work in progress, is modeling very rare events. But in general, the generative models have been quite good at capturing the patterns in the data, and therefore you do not need to know how the data is going to be used eventually in order to create to build fit these models. One other question that often comes up is how large do the source data sets need to be? So let me address this point up front. Because in our case, a lot of our initial projects were with clinical trial data sets, which tend to be quite small data sets. We've developed generative models that work well with small data sets. So generative models can be scaled down as well as scaled up. So there's a toolbox of different techniques that can be applied depending on the nature of the data. Size is one factor. You need specific techniques that will work with small data sets and different techniques that can be applied to larger data sets. Another factor is whether the data is cross-sectional or longitudinal, because again, different techniques are needed there. For longitudinal data, which are time series or data over time, or data sets with multiple events that occur typical examples, electronic health record data. So those require a different set of techniques. So a point that we'll return to later on is you really need to have a toolbox or multiple modeling techniques in order to have the capability to synthesize different types of data sets. So size and cross-sectional versus longitudinal are two factors. There are more factors that would be used to select the appropriate technique. The concepts behind data synthesis have been known for a few decades, but the area really picked up in the last few years because machine learning methods for creating synthetic data have improved quite a bit. And also demand for large volumes of data has also grown quite rapidly over the last couple of years. I think another very interesting concept that we should start talking about are data simulators. So generative models that are created during the synthesis process can be considered as data simulators. This means that the synthetic data can be generated from the simulators without having any access to the original data. Therefore, by only making the data simulators available, it's possible to enable data users to directly get access to realistic data. And you can think of this as a new form of data sharing without providing access to the real data, which brings us to the concept of simulator exchanges. We take the concept of a simulator one step further, and we can have a simulator exchange, which is another quite powerful way of sharing non-identifiable data with a broader community, except that instead of sharing data, we're sharing the generative models or the simulators. When I say you share the generative models, I mean that you provide access to the generative models so that users can use the models to generate synthetic data. It does not mean that you share the actual models with the users. Providing access allows you to control how the models are accessed, how frequently, and monitor their utilization. But it enables broader access to the data or the information that way. So simulator exchange is a catalog of generative models. A data user searches for the type of data they want, and then they find the appropriate simulator from which they can then generate data. They can generate a few records or a very large number of records once they have access to the simulator. It does not matter how large the data source is, or the source data is. Once you have the simulator, you can create an arbitrary number of records. We found that data custodians are much more comfortable sharing simulators than they are sharing data. Simulators are one step removed from data, and the generated data from the simulators is not considered person identifying information. Under this scenario, the data consumers are not accessing real data. They only access the simulators, which allows you to have quite an open simulator exchange and essentially democratizing the access to data by making it available to more people within the organization. And as I mentioned before, one advantage of simulators is you can track utilization for security reasons, but also for to understand how data is used, how frequently it's used, and by whom data is being used. There are more, even I think, more powerful approaches and things you can do with synthetic data. But I think from a privacy perspective, the concept of a simulator is an interesting one because it gives us additional ways of making data sets available. So in general, there are two strategies for creating synthetic data. These are the creation of fully synthetic data and the creation of partially synthetic data. So let's step back a little bit and examine these concepts, some of the concepts behind re-identification risk to understand what this means. When we evaluate re-identification risk, we typically only look at the quasi-identifiers. So these are the variables in a data set that can potentially be used by an adversary to identify a data subject. Almost all known re-identification attacks that were successful used these quasi-identifiers. So examples of quasi-identifiers would be age, gender, postal code of residence or work, ethnicity, race, and language spoken at home. In addition to quasi-identifiers, there'll often be other kinds of information in the data, such as which we call sensitive variables. So these kinds of sensitive variables are not very useful, or we don't consider them for re-identification attacks, but they represent information that an adversary would learn about an individual if they're successful in their re-identification attacks. So notice in these examples, there are no direct identifiers, such as names or addresses. We assume that these direct identifiers have been removed from the data already or have been pseudonymized. So we're assuming we're looking at pseudonymized data here. So most common methods for creating non-identifiable data are identified using that information. This approach only as identifiers are synthesized. This can work very well, but it requires manual intervention by an analyst who needs to decide what variables in the data are quasi-identifiers. Doing so requires training and judgment, which comes with experience. A big part of a statistical disclosure control expert's effort is deciding on what are the reasonable quasi-identifiers that would be knowable by an adversary, and manuals have been written on this topic. How do you select quasi-identifiers, what are reasonable approaches, etc. With fully synthetic data, the whole data set is synthesized without the need to focus on the quasi-identifiers only. The big advantage here is that there's no manual intervention needed. So the whole real data set goes in and the whole real synthetic data set comes out. So this is a significant advantage for data synthesis because it's now a largely automated process. Organizations or data custodians can ingest their data sets and create non-identifiable variants quite efficiently through this full data synthesis process. This is computationally intensive, but it does not. It does not require 6 months of training an expert to do it, and can be scaled relatively quickly to large numbers of data sets. I'm not saying that the effort is zero. It's just it's less effort than having to go through and parse out a data set to quasi-identifiers and sensitive variables and then just focus on the quasi-identifiers. So two different approaches for synthesis, each with their own advantages and disadvantages. Partial synthesis is sometimes necessary for very complex data sets. Some data sets, especially in the health domain, are quite complex that creating fully synthetic data sets is not easy to do, and therefore partial synthesis is a solution. It still protects privacy in the sense it's equivalent to existing methods for creating anonymized or non-identifiable data, but it's more labor intensive than if you're able to automate the whole process. So let's just dig a little bit deeper into privacy risks and the privacy risks of synthetic data. I'll just present basic concepts here so we're all on the same page, and then I'll show some results on identifiability risks in synthetic data. So the identifiability of any data set about people can be placed on this identifiability spectrum. So this is a probability scale with values of 1 and 0 at either end of the scale. So one side of the identifiability spectrum is data that's identifiable. Such data will have the name and address of the individual in it. At the other end is data that's not identifiable, which means it has an identifiability of 0. Such data does not really exist because there's always some residual risk, however small. There's a residual risk of an individual being correctly linked to a record. So 0 identifiability is not a realistic standard that we should be aiming for. There's always going to be some risk, but just conceptually, it's good to have anchors at both ends of the spectrum. So we split the spectrum into two parts. There's a threshold that's defined, and the data sets that sit on one side of that threshold are considered to be personal information, and the data that sit on the other side of that threshold are considered not to be personal information. There are many precedents for deciding on what that threshold should be. Many organizations have been sharing data for decades, and they have established rules and conventions about what is deemed to be acceptable risk. And everyone copies from everyone else. So there is some consistency around the range of values that are deemed acceptable. So these thresholds that are based on precedents do not have a theoretical underpinning behind them, because I've been asked that question, what's the theoretical underpinning for a particular threshold? There really isn't one. They're used by convention. They've worked well in practice in that when an organization goes through the effort of measuring the risk of re-identification and setting these thresholds, the resultant data sharing mechanisms have been relatively robust. And then the previous presentation mentioned some of those thresholds that are used in the health sector as recommended by organizations such as the European Medicines Agency and Health Canada. So when we create non-identifiable data, we first have to apply transformations to the data to move it from personal information side to the non-personal information side. So this is what data synthesis does. It moves the data from personal across the threshold to non-personal by generating the synthetic data. And we can empirically evaluate the risks as well. So we can measure the risks of identifiability for synthetic data. So let's look at that. So one of the key privacy risks in synthetic data is identifiability. So this means that a synthetic record can be matched with a real person. In principle, this should not be possible because there isn't a one-to-one mapping between the synthetic records and real people. However, if the generative model that is used to produce a synthetic data is overfed, or the original data is trivially simple, then some of the records in the original data may be replicated in the synthetic data. As a very simple example, if you have a data set with two variables, let's say, gender and age has two categories. So essentially, there are only 4 possible values in your data set. If you create a synthetic version of that data set, you will almost certainly be replicating some of the original records. So there are situations where synthetic data, the degenerate situations, but there are situations where synthetic data can replicate the original data, and therefore it's useful to have tools to empirically evaluate the privacy risks of synthetic data. So we developed a privacy model for evaluating this type of risk in synthetic data. And this privacy model looks at attribute disclosure conditional on identity disclosure. So here we show the results of evaluating the identifiability risks using this model on 2 health data sets. The first one is the Washington State Hospital Discharge Database, and the second is the Canadian COVID-19 Case Database. And this has been published, and the references are at the back of the slide deck. So the numbers in the table are these attribute disclosure conditional identity disclosure risks for the fully synthetic version of the data sets, as well as for the original data sets. So first, we can see that the risk in the synthetic data is significantly lower than the risks in the original data. Therefore, the synthesis process has managed to bring the identifiability down by quite a bit. Then the next question is whether the identifiability is low enough. So we're using the 0.09 threshold here. And as you can see, the risks are, for both of these cases, for the synthetic data, is below the threshold by 5 to 10 times. And we see this pattern frequently when we're evaluating synthetic data sets, that the measured attribute disclosure, conditional identity disclosure risk is significantly lower than this threshold. Let me just talk a little bit about this threshold. It's defined under ideal conditions. This means that it assumes that the data has no errors, that the adversary knowledge is correct, that the adversary knowledge is temporally consistent with the actual data, and that all suspected matches can be correctly verified. In practice, none of this is true. In practice, these factors have a non-trivial impact on the risk, but they're not always easy to model. So as with any model, we have to make simplifying assumptions, and the simplifying assumptions for these thresholds are what I just said, and these are kind of ideal conditions. But if you do take into account and you are able to model these factors, then the true risk is significantly lower. But we simplify and we use those thresholds to allow us to manage the risk, knowing in practice that the real risks are lower if we go through the additional effort for any particular data set to model all of these variables. So that's just a comment on the threshold to kind of help explain how to interpret it. So while attribute disclosure, conditional identity disclosure is the main type of privacy risk that is evaluated on synthetic data, another type of risk is membership disclosure. Because that's a bit more complex to walk through, I'll just say that the assessments of membership disclosure for synthetic data by us and others have also consistently shown that risk is quite low in practice as well. When the synthesis is done well, you can always have degenerate situations, but in general, when it's done well, the membership disclosure values have been quite low as well. Okay, so let's talk about the privacy utility trade-off. One of the important questions concerns the quality of the data that is generated by data synthesis. If the quality of the data generated through data synthesis is not good enough for actual uses, nobody will use it. So then this will all be a futile exercise. So we really need to care about data utility. As with many privacy-enhancing technologies, there's a trade-off between the privacy protection and the utility of the data. So that trade-off is shown on the slide. So a data set with maximum privacy will not have much utility because it will likely require a large amount of transformations. And a data set with maximum utility is essentially the original data set. So this curve on this graph represents the trade-off. As we implement more protection, we will lose some utility, but you want to minimize that utility loss. So in the next few slides, I'll show you some examples of the utility of synthetic data. We'll look at one of the data sets that we have already considered, the COVID-19 data set. So one way to evaluate synthetic data is to build complex models on the original data and on the synthetic data to see if they produce the same results. So we'll start off by looking at some simple comparison and then move from these simple comparisons and look at whether machine learning models built from the generated data can give us valid results. So a simple way to evaluate the utility of synthetic data is to compare the marginal distributions of the real and the synthetic data sets. And here you have two examples. The one on the left is the relative date of individuals reporting a COVID-19 positive diagnosis, and the second one is BMI. So from two different types of data sets. As you can see, there's concordance between the real and synthetic data. It's not perfect, but it's pretty close. If it was perfect, then we've basically replicated the original data set. So there will be some differences, and these are to be expected, but the synthetic data should be able to reproduce the overall patterns in the original data sets quite well. And the patterns can be unusual, bimodal, skewed, etc., and these are generally reproduced quite faithfully. However, these comparisons are somewhat simple. When you have hundreds or thousands of variables in a data set, it's difficult to draw general conclusions about the data set by looking at a large number of comparisons of these marginal distributions. So another way is to build complete models from the real and synthetic data and see if you are reaching the same conclusion. So we'll look at this example. So here we're looking at the mortality of patients who tested positive for COVID-19 over time. This is the Ontario COVID-19 case database from January 1st, 2020 till the end of November 2020. So as you can see, there's the first wave, and you can see the second wave is just about to start. Here we show mortality for the real and for the synthetic data. We built a machine learning model. So this was a gradient boosted decision tree model to predict mortality. And the x-axis is the relative date starting from the 1st of January, and the y-axis is the probability of death of individuals who've tested positive. and around the lines, you can see that they're 95% confidence interval. So as we can see here, the graphs are quite similar. They're telling us the same story about what's happening. And this is a conditional partial dependence plot, so it's factoring out all the other variables. It's really just looking at the impact of time, factoring out other covariates. And what this is showing us is that mortality of time is quite similar between the real and the synthetic data sets, and the substantive conclusions you would draw from the real and synthetic data sets would be quite similar. And you can see also, the confidence intervals are wider at the beginning because there's fewer observations, less data, and then it narrows down as more data is gathered over time. So there's pretty good concordance between the real and synthetic data sets here for this real example. This is another plot. Again, modeling mortality, but this time by age, factoring out all the other factors. And here you can see the predicted probability of death and the 95% confidence interval as it varies with age. And the results for the real and synthetic data. And the numbers on the top are showing the confidence interval overlap. So the confidence interval overlap is quite high. And there's, again, strong concordance in the patterns that are seen between the real and synthetic data sets. So we see this pattern frequently, and it's really interesting to do this for complex models rather than just looking at simple marginal distributions, comparing distributions, or looking at simple pairwise relationships. You want to build complex models as people would do with real data and compare the results to assess how good the real and synthetic data results are. So we've developed a utility framework. We've published a utility framework that summarizes some of the main methods that have been used in practice to evaluate the utility of synthetic data. In reality, only a handful of them are being used, but we think that all of these utility evaluations are useful to be performed either once or on a regular basis on synthetic data, just to get a better understanding of the quality of that synthetic data. So Let me talk a little bit now about comparing synthetic data with other methods that have been used historically, to do a bit of a contrast, to explain what does synthetic data provide compared to traditional methods that have been used for data anonymization, and what are the advantages and disadvantages, relatively speaking. So the traditional approach thus far, again, in practice, that's been used to managing rate identification risk, certainly in the health sector, is to transform data and to implement controls. So it's a mixture of data transformations and controls. The combination of transformations and controls give the analyst, the statistical disclosure control analyst, multiple levers to manage the risk and ensure that identifiability is below that threshold. It allows one to maintain high utility by implementing a few transformations and then managing the residual risk through the implementation of additional controls. In this case, these transformations mean things like generalization suppression. So generalization is when you say convert a date of birth to 5-year intervals, and suppression is when you remove an unusual value from the data, such as the 16-year-old girl with a PhD, for example, would be an outlier. So these are typically the methods that are used. And then you have controls, which are security controls, privacy controls, and contractual controls that would be put on the processing of the data to manage the residual risk after the data transformations. So in practice, this model has worked very well until it didn't. Let's examine this the situation here in a bit more detail. So we have data transformations and we have the controls, and we have low and high data transformations and low and high controls. And as a general rule, data consumers want to make sure that the level of data transformations in their anonymized data is low, since that maximizes data utility. Business leaders are very focused on data utility. So the quadrant at the bottom left right-hand side is the one that is of ideal one for data consumers. And that is low data transformations and low controls. Because there are low controls, the operational cost is also low. So you end up with high data utility and low operational costs. And the challenge here, of course, is that this quadrant is going to have a high privacy risk, because you're basically not doing very much to protect the data. You have few transformations and few controls. And as data sets are becoming more complex, the amount of data transformations that need to be applied to reduce the risk is extensive, and therefore there's even more pressure you can't, like, there's more pressure not to implement the controls to maintain the data utility, which brings us to this quadrant, which is where we typically end up. Here we see many organizations doing this, where they maintain low data transformations to maximize utility, especially for complex data sets, but then they implement a large amount of controls, high controls, to manage residual risk. And this means they get their high utility, but they end up also with high operational costs. What this means in practice then is that the operational costs for processing anonymized data, or data that's claimed to have a low risk of identification, have become quite high. And it also means that we're effectively starting to treat data set that's supposed to be anonymized as if it's personal information, because we're implementing more and more controls to manage the risk. So that's the first problem, is that the economics are becoming more challenging following this approach, because to maintain high utility, as data complexity increases, you have to implement more controls to manage the residual risk, which means the economics of processing anonymized data are becoming more challenging. It's just becoming quite expensive to process non-personal data this way. And this also creates a regulatory challenge, because we're seeing data sets with minimal controls that are relying extensively on, with minimal transformations that are relying extensively on high controls to manage the residual risk. But let's focus on the economics. The economics are becoming more challenging. The second challenge with existing methods, again, this methods that I showed you earlier on, is the erosion of trust. So you can see there's a lot of headlines over the last few years describing ways that data has been attacked or has been re-identified. I'm not going to comment on the validity of those papers or articles or attacks because there are a lot of questions, and that's a whole other topic about the validity of those and what we can really learn from them, kind of moving beyond the headlines. But it doesn't matter. The negative narrative exists. The headlines are there. And the discourse that has developed around traditional methods for creating non-identifiable data is that these data sets can be re-identified with increasing ease. And this has resulted in erosion of trust among civil society, among the public, and among regulators as well. And I hear that very often from organizations and data custodians and controllers, is to what extent can these methods be trusted given these types of headlines and this kind of narrative that exists. The next challenge with existing methods is that the skill set requirement. So in order for an expert to do proper statistical disclosure control, they are training. Very few people receive that training through regular education, so this additional training required. It's, I mean, I did this before, 6 to 12 months of training in order to make someone experienced enough and knowledgeable enough to be able to perform these risk analyses themselves. And there are not enough people. The skills are not very common and requires a lot of training and judgment as well. So this is where data synthesis becomes interesting for those three reasons. One is because you rely less on controls to manage residual risk. The economics are more attractive. From the trust perspective, that the current evidence suggests that the privacy risk on synthetic data are lower. It's not a panacea. There's always risk. The risk is never zero. And you can mess it up. You can do synthesis poorly. But if it's done well, the evidence that exists so far is that synthetic data can produce data sets with a relatively low risk of re-identification, defined as attribute disclosure, conditional identity disclosure, and as membership disclosure. And then the skill sets are minimized. The process can be largely automated, as we discussed before. And this is improving over time. There's a lot of innovation happening in this space. Therefore, the level of automation is increasing, but it reduces the skill set requirements as well, which makes it easier to use. So, of course, there are a number of key questions about synthetic data that come up from a regulatory perspective. And one way to answer these questions is to treat synthetic data as traditional non-identifiable data. But I think it should be kept in mind that synthetic data is not real data. They're data that are generated from models. And the analogy I like to draw is if I get a published article in a journal that has, say, a regression model in it, and if the regression model that's published in that journal and the descriptive statistics around the regression model are complete, I would be able to generate reasonable synthetic data from that model. I'd be able to generate with reasonable confidence the raw data that was used to create that model. Should then the uses of published models in the academic literature be regulated? Because again, we have a model that's published. We share models all the time. We've been doing that for many decades. And if we're able to generate synthetic data, plausible synthetic data sets from these models, do you want to start regulating those models? Because that's essentially what we're doing now when we create synthetic data. We build a model and we're generating data sets from these models. So I think that the evidence supporting the low risk is accumulating. The evidence supporting utility is accumulating. I think what we need, as in the previous presentation, we need some guidelines and guardrails around this, around how to evaluate those privacy risks. It's a good time now to do this because we're in early stages and it's possible to shape the trajectory and put guardrails for what happens, and that will accelerate adoption, but it'll also provide assurance for data producers, synthetic data producers, and synthetic data consumers that the risks are low. So let me quickly move into the next and last topic, which is discuss specific techniques for the generation of synthetic data. I'll just give a broad overview to kind of orient everyone. I think some of those topics will be discussed more later on. I'll just discuss some of the more common techniques. So the first one is sequential synthesis. Sequential synthesis typically uses statistical machine learning methods such as trees or boosted trees to synthesize data. It has the advantage that it can readily handle heterogeneous data sets with different variable types. It can handle missing data. It can work well with relatively small data sets. It can handle a very large number of variables, and the computational efficiency can be quite high. But the basic idea is that each variable in a data set is synthesized in sequence using variables earlier in the sequence as predictors. And in addition to the usual tree or boosted tree hyperparameters, the order in which the variables are synthesized is also a hyperparameter that needs to be tuned. And then a typical training loop is shown on the right-hand side here, where you use a discriminator to distinguish between the real and the synthetic data. And the discriminator is a classifier that takes as input the real and the synthetic data and predicts whether a record is real or synthetic. The accuracy of those predictions or classifications is then used as a loss function to tune the hyperparameters for the generator. So the objective is for the discriminator not to be able to tell the difference between the real and synthetic data. And when you reach that point, then you have a generator that's producing high utility or good enough real data, and you can inject privacy parameters in the loss function as well. So the discriminator provides one input to the loss function, and you can also include privacy risks as part of the loss function. So the generator is automatically trained to balance these two things together. In practice, these types of synthesizers work very well and can produce results quite fast, and they can scale up and scale down. Another approach that's used quite frequently, now this one uses neural networks, and this is just again conceptually variational autoencoder. The basic idea is to take a data set and train a neural network to create a compressed representation of the original data. So this compressed representation, that bow tie in the middle, is essentially typically a multivariate normal distribution. And you train a neural network to create that multivariate normal. And then the second part, the decoder, takes that compressed representation and tries to recreate the original data set, which is a synthetic version of the real data, basically. And the neural networks are trained to minimize the difference between the real and the synthetic data. Because of this compression, the recreated data will not be exactly the same as the original data set. So VAs are another popular architecture for the creation of synthetic data, but they do require a lot of data to train them well. And then the last architecture, which is also very common, are GANs, generative adversarial networks. And here you set up two neural networks where one is creating synthetic data and the second one is trying to tell the difference between the real data and synthetic data. So essentially a discriminator like we saw before. The only difference here is that the generator, which is a neural net, is taking random data as input, which could be uniform or Gaussian distributions, but some random data, which is then converted to synthetic data. And then you use the results of the discriminator to train both of these neural networks. So GANs can work very well when the data sets are large. They're a bit challenging to train, especially as data sets become more complex. At the end of the day, you want to be able to automate the whole cycle, and you don't want to have to manipulate the tuning and the structure of these generators for every data set. But once they're working, they can produce very good results. So the examples I showed you here work well for tabular data. There are architectures that work for longitudinal data as well. They're more complex architectures, and they can also combine some of those techniques that I described to create hybrid architectures to create synthetic data. I think a key point that I will make here is that you really need to have a toolbox of techniques, in the sense that different techniques will work very well. They have the strengths and weaknesses, so work well in some cases. And having a toolbox allows you to select the best technique given the nature of the data that you're working with. And there are a number of criteria that are used to select the appropriate technique, and a bunch of heuristics that have been developed over time to analyze the data set, determine based on the characteristics of the data, which approaches work best, and then apply the best technique for that particular data set. So that is my presentation. Hopefully I gave you a useful overview of the topic of data synthesis, privacy, and utility. And I'm happy to answer any questions.
Thank you, Khaled. That was really a great, an extensive, I would say, tutorial on the use of synthetic data and the relationship with privacy and data protection. I think that will be, very much appreciated. We have several questions, I would say. I want to not to go necessarily in timing order. So you mentioned that there could be synthetic data poorly generated, meaning that there are automatic methodologies which are ensured by the automatism that you have keyed in, but still there should be some, good way of using them. What assurance can a synthetic data user have, I mean a customer, I would say, or without internal access and understanding of the generative model, meaning that, how do you, give this kind of assurance to someone that says, I want to use the data at the same time, there should be utility, I want to preserve privacy. I mean, what kind of communications? Because here you have very intensive statistics and mathematics, elements that are not easy to understand to the large public, I would say. I would say even more. So that's the question. Thank you.
So you can produce privacy assurance reports and data utility reports for every single data set that's produced. And the privacy assurance report would have or should have the metrics for the privacy test that I mentioned. So, I mean, the two that I would recommend, which there are many proposals, so that's great. There's a lot of activity in measuring privacy risk for synthetic data, et cetera. But the two that I think are the most meaningful are attribute disclosure, conditional identity disclosure, and membership disclosure. And there are different ways to operationalize these, but I think directionally these are the two types of risks that should be looked at. So produce privacy assurance reports that measure those types of risks on the data and produce them, produce the numbers and compare them to the thresholds, and that can provide assurance to the data consumers that the privacy risks have been managed. And as I mentioned, the thresholds, I don't think that's a controversial topic. They're pretty well established precedents for those. So you really need to demonstrate that your risks are below the thresholds. And then the same thing for utility. There are a number of different utility metrics that can be used, and a utility report would document that and provide assurance to the consumer of the data that the data utility is acceptable. So I mean, that's what you should do. In an ideal world, there are standards and consensus on what privacy metrics should be used and what utility metrics should be used. And there are efforts now to try to do that, to help with ensuring consistency across all the different tools that are out there. But at least I'd say that's the minimum you have to do: privacy and utility reports, analysis for every single data set.
Thank you. Another question is the following. Maybe you already have answered to that, but maybe I go quickly on that. Could you elaborate, please, on how synthetic data can help in data science projects? Will it identify the patterns in the data, and will it be possible to reach the same conclusions? I think it might be inherent, but you can say something about that. And another question is, could this lead to bias? I mean, this process lead to bias amplifications and problems with explainability? Now you have replied to explainability. I saw that synthetic data can help also to reduce bias. You say there are certain points, but could not be also the opposite. So can you say something about that?
Yeah, I mean, let's say vanilla synthesis will replicate the biases of the original data, because you're trying to replicate the patterns. You learn the patterns in the data, and then you produce data that retains those patterns. So there are biases in the original data, that you'll get biases in the synthetic data. So I think that's kind of the starting position. However, you can do things to reduce bias. So you can create data sets that are less biased, depending on how you define bias. And you can use data synthesis as a tool to reduce bias in other data sets as well. So I mean, I think synthetic data generation can play a role in bias reduction, but it has to be a deliberate effort, because the default is biases in real data will be present in the synthetic data. In terms of explainability and interpretability, I mean, I showed you some results here. You have data, you have synthetic data, and if you are able to do some interpretability analysis on your data and examine the variable importance and functional relationships with real data. You can do with synthetic data. I think the interpretability techniques would be applicable with real and synthetic data sets. I don't see that as being at least the technique level, I don't see that as being a disadvantage.
Yeah, thank you so much. I understand that the privacy gain in using synthetic data, you're explaining that in the articles that you have referenced, you say in your slides. Am I correct?
Yes. Yeah.
Okay, thank you so much. That's very important, so that people can have a look at that, in particular those who want to understand a bit more in depth, because here we cannot go into this kind of nitty-gritty detail, which are at the end of the day the most important ones, because are the ones that define really whether it works or not. And another question is, I understand that in these, you have shown at the end several methods to produce synthetic data. I understood that in this box called discriminator, you also have some controls in order to rectify or to implement the privacy, let's say, measures. Am I correct? And how much this depends on the specific? You showed two use cases before, and the privacy gain for them. How does it depend on the type of data, meaning dimensionality, or the statistical distribution as well, or how much this is automated? What kind of confidence we can have that when someone provides an automated infrastructure, this can work, for all the cases? So do you fine tune when you offer this kind of products, what you call, if I'm not wrong, you call it the simulators at the end. That is the one that you share. Thank you.
Right. So when you train a generator, you define a loss function, and you can include privacy metrics inside that loss function. So it can be a complex loss function or a complex loss with the measures from the discriminator, ability to discriminate. You can also include privacy metrics in there. And that way, and then so you can use then the combination of those for training, so that as you're training, if the privacy risks are going high, then your loss will increase, and then your training will try to adjust for that. So, and as we develop privacy metrics, that becomes easier and easier to do. So, and we're getting there. The second part of your question is how easy is it to do for complex data sets? I think for tabular data set, this is a solved problem. For longitudinal data sets, there are good models that are around, that have been developed for just traditional de-identification, which are now being applied for synthetic data. So I think that's a problem that's going to be solved, being able to measure privacy risks on longitudinal data or more complex data sets. But for privacy measurement, for that part of the process, you do need to identify which variables you want to treat as quasi-identifiers. So that step needs to happen still for the privacy assessment piece, not for the synthesis piece, but for the privacy assessment piece. So that part cannot be automated fully, maybe partially automated, but cannot be automated fully. But once you've done that, then the rest of the process can be automated. So, and if you have a standard data set or a standard schema, then you can make those selections of quasi-identifiers at the outset, and then standardize, kind of automate basically the privacy assurance piece as well. So I think we're getting there. We're not quite there yet, but I think we're getting there in terms of combining privacy measurement within the training cycle. The only disadvantage, or one of the disadvantages, is that it becomes quite computationally intensive at this point to incorporate privacy measurement in the training cycle as well, because privacy measurements can be computationally intensive as well. So again, if you do it well, the best risk estimators are computationally intensive, and so the process becomes computationally intensive. But beyond that, I think being able to produce data sets that balance privacy risk and utility is going to be quite achievable. I think before the end of the year, we'll have tools that do this.
Okay, thanks. Someone asks whether, I think you somehow replied, but in the context of DPIA, what variables are considered to evaluate the re-identification risks?
So, I mean, this will depend on the data set. So there, I don't think there's a general answer. There's a process you can follow for sure. There are well-defined processes that can be followed to answer that question. But in terms of what variables specifically, that will be a data set dependent answer.
Okay. Yeah, someone says, how robust is deep neural networks-based synthesis when assumptions on the DNN training data do not match with the properties of the data faced in the real world?
Well, you train the neural network based on real data, so that way you mitigate that to a large extent that concern. I think the neural networks can work very well. I mean, there are a couple of perspectives. One is that look, for some data sets, traditional statistical machine learning methods can work really well as well, and they're much more efficient and easier to manage. So you have to choose the right technique. I think jumping to neural networks right away is a common practice, but it's not necessary because traditional or more commonly statistical machine learning methods can still produce very good and comparable results. However, for some very complex data sets, you do have to use deep neural networks to build the models. There are really no other alternatives. But then you need to have larger data sets as input to do that. So like I said, it's a toolbox. You have to understand the strengths and weaknesses, and you choose the best tools for the particular characteristics of the data. Once you understand that and you're able to develop heuristics to choose the best tools, then you'll be on a more optimal path, more efficient path to produce good synthetic data.
Okay, so I understand that still, I mean, you're working on that, but still there are at least 2 or 3 kinds of different competencies that are needed in order to have some reassurance, I would say, despite the automatism that you said are in the in the tools. Okay, I think we can stop here. Otherwise, we cannot go for the, let me see the program, for the agenda for the coffee break. We have so many questions. I think that we cannot, of course, finalize our considerations all now. We will have also other 2 practitioners after the break. So Professor Lehmann, we thank you so much for your intervention, and we offer what you say to the assessment of all our people and the people that are attending, and in particular we thank you so much, and we hope you can stay also for the next part. Thank you.
Thank you very much. Have a good day.
Bye. You too. So now we go for the coffee break, and we come back in 10 minutes. It's not a long coffee break, but I mean, I think we can refresh for those who suffer a bit of hot weather, in particular around Brussels. And okay. Thank you for following us so far. Stay with us. We will come back at 3 o'clock, possibly sharp. Thank you. So I think we can recover and come back. And thank you, Florian, for joining us. We are at the second part of this first big session for practitioners, and we have had before Stephen Bamford from Janssen and Professor Khaled Eleman from Ottawa University and from Replica Analytics. So, Florian, very happy to have you with us. Florian Schroff is team lead for computer vision and machine learning algorithms and products at Google, where he conducts applied research in the areas of computer vision and machine learning. His projects focus on describing people in images and videos. Before joining Google in 2011, he completed a 2-year postdoc at the UC Division Group, where he conducted research in unconstrained face and object recognition. Specialties are computer vision, face recognition, machine learning, and big data. So, Florian, thank you for joining us. I give you the floor. Thank you.
Hi, everyone. I hope you can hear me well. Good morning or good afternoon, depending on where you are. And thanks for having me here. I'll talk about synthetic faces in particular to improve privacy and fairness. And mostly I want to set up the problem to make everyone understand what we're thinking about and what the constraints are. First, some background. So the development of AI is creating a lot of new opportunities to improve the lives of people around the world. And it also, in particular, brings new ways to build fairness and privacy into these systems. And this latest part is what I'm really focusing about in this talk, what the opportunities are that we have with synthetic data. So as it was mentioned, I'm working on, in particular, on image understanding. In particular, a lot of the work we do is on faces and people understanding in images. And there's a lot of great opportunities and use cases for semantic understanding of faces. And it's key to many human-machine user experience, machine-human interactions. For example, use face detection in cameras for auto exposure, to organize personal photos, or to detect attention for interaction with smart devices. But there are many difficulties in developing these models. And so specifically around data, we need very large scale and demographically diverse data to build fair models that work for everyone. And then in particular for work related to faces, it requires special legal and privacy considerations. And this is really where synthetic data can come in. So just to highlight, this is the way we are thinking about it. To build these models, we need very diverse data sets. We need large scale, large amount of images representing many identities, many devices, many types of environmental conditions, lighting, etc. And then we really want to do this in a privacy preserving manner. And synthetic data can help with this and can allow us to reduce the reliance on real world data while at the same time making it work for more people and under more conditions and at a very high quality. A little more background. So at Google, we are and have been committed for the responsible development of face-related technology. We were one of the first companies to decide not to release a general purpose face recognition API. And we are developing other face-related technologies in a responsible privacy-preserving way that are aligned with Google AI principles. And so this is where we think that synthetic data can really help the progress. And some ways that can happen is it can simulate a diverse set of populations it can amplify the effectiveness of personal data. So if you have a smaller subset of people that consented, collected data, then we can train generative models and can generate large amounts of diverse data based on this smaller initial set. And then these synthetic generative models can also help test our models by means of counterfactual fairness, for example, modifying certain attributes, and then testing how our models perform on that data. So the question is, how can this be accomplished in a privacy-preserving manner? And some of the common techniques for privacy-preserving data generation or even data set anonymization is differential privacy. There's one paper here that is from a related team at Google. Text image, they use generative model to generate text and image data for debugging. And there's a lot of other related work. I have some more pointers later on. But basically the positives, the pros of differential privacy is can protect against data leakage, for example, in deep learning models that are trained on a smaller set of real-world data. It can provide formal guarantees for anonymization. The downside is it may sacrifice some utility of the synthetic data depending on the privacy bounds that you're working with. Another common method is k-anonymity that makes sure that at least k-1 individuals in the data set are comparable or indistinguishable from the other individual. That one is prone to linkage background knowledge attacks, but also it's not clear how it can be applied to images, for example. So here's an overview of some of the related work. Differential privacy seems to be emerging or is emerging as a viable path for privacy-preserving machine learning. This is some of the earlier work by Abadi and Dwork. And then there's some really interesting recent work as well. This work by Cohen et al. Tries to put differential privacy into legal context and discusses what various types of anonymization could mean and how to formalize that. And then there's some more recent work that proposes using differential privacy to anonymize facial imagery, and in particular in this paper they propose releasing the generative models instead of releasing data sets. So one advantage is that it really allows the user to generate as much data and potentially also tweak the distribution to their needs. And because of the guarantees of differential privacy, that all this generated data will still be anonymized and adhere to the guarantees by differential privacy. So just to kind of summarize and highlight the way we're thinking about this. So if you train, let's say we want to train a face generation model, you train it on these 9 identities, and you can generate synthetic faces. Then differential privacy gives you a guarantee that if you remove one of these faces, the generated faces will be indistinguishable from the original set. So it guarantees that there's no membership inference attack possible. So you can't find out if any individual was part of the original training set. It's robust against memorization. So the model cannot output one or more input phases verbatim. I'll talk about that a little bit on the last slide. And also non-person specific information is protected and aggregated and anonymized in the models. Yeah, and so to summarize, to have these models that are privacy preserving, we need to protect the user privacy. If we're using facial imagery, enable building great products that rely on large-scale diverse data is really one of the goals and one of the opportunities for synthetic data. And differential privacy algorithms, when applied to, for example, categorical data, have been shown to be very suitable to render synthetic data in an anonymous, privacy-preserving way. So one thing that came up in our discussions and when we were thinking about this is there a difference for faces? And I really kind of want to pose this as an open question. For example, if I mentioned on the earlier slide that we have these privacy guarantees that faces are not generated verbatim, but it could happen by chance. For example, if you have a generative model that generates phone numbers, it could generate someone's phone number. Either that person could be part of the training data, or it could be just someone else's phone number. And the same could happen for faces. And yeah, I want to pose this as an open question. Is that something that's is that the same as with a phone number, or is it a different case? Because these are faces. If you see someone's face and you recognize that person, then it might really be a different thing from a user point of view. And yeah, with this, I'm at the end of my slides. I don't know what how the questions work. I'm happy to take questions, answer questions, or if that's in the Q&A later. Thanks, everyone.
Thank you, Florian. So we, differently from the previous sessions where we had separate Q&As for reasons linked to availability of the speakers, now we are going for a Q&A which includes also next speaker, who is Omar. Omar, if you are already ready, despite we are a bit earlier, you can come to the stage.
Hi, Massimo. Just the
Hi,
time
Omar.
to set up the camera.
Yeah, thank you for accepting our invitation. So we have Omar Alif Dal. Omar is co-founder and CEO of Statis, and a company, and helps organizations safely collaborate on data with privacy-preserving data solutions. With over 10 years of software and data system designs and development, he ensured that Statis continues to stay at the forefront of research and innovation. Prior to Statis, Omar pioneered some of the first data products at Amadeus IT Group before co-founding an urban mobility company in France. So, Omar, you have the floor. Please explain us what you do in Statis. Thank you so much.
Thank you very much, Massimo, and the whole IPEN team for inviting me today. And good afternoon, everybody. As you just introduced, I'm the co-founder and CEO of Statis, a Berlin-based company where we have been working for the last 4 years with organizations of all sizes, especially large ones, and various sectors from finance, insurance to healthcare. And there we support them in their data protection efforts with a particular focus on leveraging synthetic data as a privacy mechanism. And this is synthetic data as a privacy mechanism is exactly what he'll be talking about today. So after what we've learned in the first presentations about synthetic data, especially the utility aspect and the real world use cases, such as, for example, the COVID-19 mortality analysis showed by Professor Ayman, I will focus my talk on the practical aspects of what makes synthetic data suitable as a privacy mechanism. To start, I will first talk about the main risks associated with releasing data in general, in all its forms. Then I will briefly discuss shortcomings of the most common data protection techniques, before showing how synthetic data provides a powerful privacy preservation properties. And then I'll conclude with some ideas of how to assess the main privacy risks, especially in the context of synthetic data. As everyone has just mentioned earlier, data collaboration in general provides a lot of value for organizations and society in general. And yet we have frequently seen many ways that data collaborations and sharing can go wrong. And the two main risks of the data projects or the data release are related to two things. And the first one is the identity of the data subject. And the second one is the personal secrets of the people. And these are translated into risks as re-identification risk, where the exact identity of a person is leaked, and inference risk or attribute inference risk, where the exact secret attribute of a person is leaked. Now, I'll be omitting also the membership inference risk for this call, but I think it was also mentioned in the previous talks. Now, in order to illustrate the re-identification risk, I will take the classic example of the Netflix re-identification case. So Netflix, a few years ago already, wanted to build a better movie recommendation system and thought the best way to do it is to let a community of enthusiasts from everywhere compete for a significant money prize. So they took that data, they pseudonymized it by removing unique identifiers such as the names and some other identifying information, and noised it maybe slightly by perturbing the exact ratings and the dates in which those movie ratings happened. What happened next was that they actually got a much better recommendation engine, but they also got a bad fame, as two researchers were able to re-identify a large portion of the users in the Netflix dataset by crossing it and linking it with the IMDb publicly available data. Once the identities were revealed, for some people, secret attributes were also revealed, like movie tastes that users did not necessarily want to expose in the first place. Now, this example, the Netflix example, shows how linkage is, or re-identification is a result of two factors. The first one being the uniqueness, and the second one is background knowledge. And about uniqueness, it has been shown already 20 years ago by Latanya Sweeney in her famous work, also of the Massachusetts governor re-identification, that three demographics like city, gender, and date of birth were enough to identify half of the American population. And if zip code is used instead of the city, this number goes to 87% of the population. More recently, a couple of years ago, Yves-Alexandre de Montjoie has showed that with 15 demographics, this number goes up to 99%. And this uniqueness means that we don't need those explicit unique identifiers like the name or the phone number or social security in order to be able to join data sets together or to join with auxiliary information and learn new things. For example, the exact identity from this newly joined view. And the other risk is the attribute inference. But first, what is inference? So according to a dictionary definition I've just found online, inference is reaching a conclusion on the basis of evidence and reasoning. And the inference risk, on the other hand, is a bit more subtle because there are two opposing forces. At the same time, we want to learn general insights from the data sample at hand. without learning highly specific information about the individuals. So we want to learn that smoking causes cancer, but not that the male person who is 57 years old and lives in zip code 35000 and who works as a high school teacher has cancer. This is the difference that I make here between the general inference, so the desired property that we'd like to get from the data, and the specific inference, things that we are not really necessarily interested in. And as we have seen right now, the risks associated with data sharing, I'll briefly look at some of the protection mechanisms that are most used today, and some of these have been already covered in previous talks. So first one would be pseudonymization, the second one k-anonymization, and then there's the extreme no data protection. All right, so a data set in its raw form looks like this, a number of variables and their values. Some of these variables are by definition unique, like the phone number or social security number. And then there are other variables that are not really unique, like the demographics, for example, the birth, the sex, the zip code, and then some sensitive information like the medical condition. Then sometimes potentially there are other data set, like other data attributes like the movie ratings that just looks like a sequence of cryptic numbers that some people might not consider sensitive, but as we have just seen, can still allow this re-identification. And the first family of protection techniques is protecting or dealing with those obvious identifiers. And here we will find things like masking or pseudonymization, where they just remove or replace the values in these obvious identifiers with either just completely remove them or replacing them with some hashes or some values that we can retrieve afterwards the original data by mapping it. So the mapping is itself stored probably somewhere else if it's done correctly, and this will provide a pseudonymous data set. Now this definitely is a step in the right direction, but merely removing unique identifiers is not enough to protect from the risks that we've mentioned, especially the linkage. And furthermore, the privacy regulations such as GDPR explicitly declare that pseudonymous information is not personal. Pseudonymous information is personal data and must be handled with the exact same care and constraints that applies to the raw data. The second family of protection techniques acknowledges the limits of pseudonymization and actually comes as a response to these limits, and go one step further to protect the variables that are not necessarily unique about the people, but could be identifying when put in combination. And here we find the k-anonymity and many of its different variants. But as Florian just mentioned in his previous call, there has been shown that k-anonymity is specifically subject to attribute inference attacks in a number of scenarios, especially due to the assumption that some columns are more sensitive than others. So this notion of quasi-identifiers, and that these quasi-identifiers are, well, beside the obvious identifiers, the only one that are worthy of protection, and then probably the others are just left alone, untouched. Now, is this effectively the safest data? Can we do better than this in order to preserve the privacy, but at the same time being able to use the data? And this is exactly the question that brought us to explore synthetic data. We wanted to provide data practitioners with the same interface that they are used to, which is the data, and make it both useful and privacy preserving. But before we go further, let me define what I mean by synthetic data. So in the following, I will hear that synthetic data is the fully artificial and algorithmically generated data that looks and behaves like the real data. And synthesization, here again, some people call it synthesis, some people call it synthesization, is the process of creating such synthetic data. And in this process, the general insights and relationships in the original data are learned, and then new, completely artificial data records are created in the same way we would draw a sample from a probability distribution. Now, this process is irreversible. There's no key that allows us to conveniently retrieve the original records from the synthetic records. This is already a strong desirable property in any privacy preservation mechanism. There is no one-to-one link between the synthetic and the original records. And this is also why in the previous definition of synthetic data, I don't include the noised data or the partially synthetic data. So data sets that take the original records and modify them slightly, for example, by changing just certain fields or certain values by certain amounts, or by just synthesizing a subset of columns and leaving the rest untouched. These two processings would not satisfy this irreversibility property. But the irreversibility is not the only thing that makes synthesization interesting from a privacy perspective. On the other hand, as any learning mechanism, synthesization is also subject to things like overfitting, which itself may cause some undesirable privacy leaks. And for this, we can also combine the synthesization mechanism with other techniques, for example, formal privacy principles such as differential privacy. It was also defined earlier in the other talks, but in general, differential privacy is a mathematical definition that ensures that no specific learning about specific individuals are learned from the data, and only more generic learnings and patterns about larger number of people. So, for example, how we can achieve this? We can achieve this by learning the distribution in a differentially private way. And if we do it in this way, the synthetic records that we sample from it are themselves differentially private. So this means that by doing this, we would benefit from the theoretical guarantees that differential privacy provides, on top of what synthetic data also provides in terms of irreversibility of the processing. So we have seen what synthetic data is, and that we can combine it with other privacy principles, but how do we empirically assess the risks outlined in the first part? I will now present two approaches to measure the linkage and the attribute inference risks that we can apply to synthetic data. The first one is the linkage potential, and the second one is the attribute inference risk. So for the linkage risk assessment, I'm introducing here an idea of the linkage potential, and the objective of this is to detect suspicious records. And what suspicious records are in this context are close matches and sensitive duplicates. In the illustration, imagine this is here a representation of our data set. There are a lot of average records, so people that maybe look like other people, except one that in particular stands out quite a bit. So this person here. This is an outlier. If the synthesization produces a similar outlying pattern, even though it is not the same record, then this is definitely a suspicious case, because this person would be leaking very sensitive information about this person, and there would be little doubt that the presence of this one here is due to the presence of one outlier in the original data. So this would require further attention. On the other hand, if in the original data there's a number of people that are looking more or less the same, and we retrieve them in the synthetic data, then this is less sensitive than the first situation. So the intuition here is that synthetic records should not be closer to the original records, at least not closer than original records are to other original records. And in a real tabular case data, we can look at this at the single record level and check that pairs of records that are classified as close matches or suspicious, and we can see that they have either close values for certain variables or matching variables in specifically in the low data density area. So we can here see that there was 180 records out of 8,000 that were classified as such. We can also evaluate this risk overall at the data set level by looking at the distribution of this linkage potential of synthetic records with original records in orange and comparing it with the distribution of the linkage potential of original records among themselves. And if the synthetic distribution is lower, as is the case in this plot, the data set presents low risk of linkage. So linkage is the first thing that you can look at, and the second thing, as I mentioned, is the attribute inference risk. And here the goal is to detect specific information leak or information that can only be learned from the specific data sample used for the synthesization, not from the population or maybe from a different sample. So in this scenario, the attacker has partial knowledge of the original data, maybe gained from knowing some open data set or maybe illegally retrieving some different data set. And they try to guess the hidden parts, so the parts they don't know, based on the full synthetic data. So here we assume that this synthetic data is completely in the open, shared for whatever reason, either openly shared or also leaked for whatever reason. If the synthetic data provides more information about the training data, then it provides about held out test data that was not used in the synthesization, then there is a privacy leak. So the intuition here is that how much further help would the synthetic data give to an attacker that already knows something about the original data set? And if we put it here in more of a formal way or plotting it more figuratively, the bottom figures here are simulating a overfitted synthesization, so a synthesization that has been on purpose pushed to learn too much specifics about the individual records. What we can see is there are three different plots. The blue one is the evaluation for the success of the attack on the training data. The green one is the success of the attack on the control data that was not used for the training. And the orange one is a baseline that is based on a random guess, data-informed random guess, so still quite informed. So the leaky synthesization, as we can see here, the blue one is way to the right than the green one, and we can see it in both plots. Now, a more private synthesization, we can see that the blue and the green are indistinguishable. They are still further to the right than the orange one, and this represents the learnings and the general learnings that we are inferring. So we are inferring better than if we were making random guesses, but we are not inferring more about the training data set than we are about the control data set. And just to conclude, what I wanted to show here is that releasing data in all its forms is challenging. We've seen the different risks that are related to it and how they also apply similarly to synthetic data. That synthetic data, when done right, as also many of my predecessors have mentioned, does provide a great opportunity to combine both utility and privacy in a large number of use cases. And last but not least, understanding the risks and the risk implications of all data processing is crucial no matter what technology is being used. And this concludes my call, and I would like to, yeah, definitely looking forward for the Q&A.
Thank you so much. Thank you, Omar, also for this, explanation, also with terms that are accessible and graphics accessible to a large public, I would say, despite the the complexity of the matter. I think that now I go to the questions that the public have posed. We have two of them in particular. I think that the first one refers to, so the question will be for both of you, and Florian and Omar. So Florian, if you would like to come to the stage, you are very welcome. You will see, you can both reply to all questions, it's up to you. The first question, I think, refers to the use of most probably differential privacy, but it will be up to you to reply. In data protection training, they say, many academic articles use epsilon, privacy budget, values so large that hardly any privacy guarantee is implied. So it seems likely sometimes data protection training is used just because it is supported to be a privacy preserving mechanism, while at the end of the day, it's actually misused. What's your comment on that? Thanks.
I can maybe briefly start about this, and it's definitely not an easy topic, especially the epsilon and measuring this privacy budget, or communicating about it, or educating people about the implications. So what does it really mean to have an epsilon 0.1 or an epsilon 1 or an epsilon 100? And this is also the reason why in what I mentioned, it is not enough to say, hey, it's synthetic data, it's private because it's irreversible, or hey, we're using differential privacy, it means that it's private. Of course, if you use differential privacy and you can misconfigure it in some way, you can still find some bad surprises at the end. And this is why the risk-based approach here is crucial. You need to understand what are the risks. I showed some empirical approaches, but there are others to measure that in a way that is not theoretical, as is done with the epsilon. I think the epsilon in general is a bound, is a theoretical bound, and it's people are researching constantly on how to measure it and how to as tight as possible, sometimes for already existing techniques. So it's definitely not an easy question.
Florian, would you like also to reply to this, or as you prefer?
Yeah, I think Omar summarized it quite well. I can also imagine that as these techniques develop and mature, that maybe some best practices develop for different data sets. And I think a lot of the work, especially what we're looking at in the images, is also still quite early. But I also agree that looking at it from the evaluation point of view, like how do we, once we have differential private data, how can we measure if there are any issues? This is another important aspect, not just relying on the formal guarantees.
Okay, thank you. So would you consider that also depends, of course, on the type of data sets? It's also the usual balance with utility. Okay. Now, another question that we have is, it was said that previously that you should keep accuracy of the model around 95%, otherwise you risk entering into privacy issues. I think, by increasing the accuracy, I guess. Is this sufficient to prevent the risk of leakage due to outliers in the data set?
I can say just maybe a few words. about that, but also about the fact that 95% of the accuracy sounds nice, but at the end of the day, it depends on your original model. We had some cases, and this is okay, sometimes maybe anecdotal, but where models trained on synthetic data even outperformed models trained on the original data. And here I'm not saying this to brag, it's just an artifact that synthetic data in some way is helping the models to generalize, so that you can actually get a better performance on test data that was not seen before than you would do it on the original data. Of course, if you spend the time and tune your model and make sure it generalizes well and everything, this effect disappears. But so at the end of the day, you need to also know your models in addition to knowing your data. So I have I haven't seen any threshold or bound to what this closeness must be to the real performance. Honestly, we haven't had any such considerations, at least not for privacy reasons.
Okay. Of course, Florian, if you want to add, you're always free to add something. Another question is, what is the life cycle of the original data fed to generate the SD? Are those permanently erased after the creation of the SD? The synthetic data, of course. I mean, I think that they ask about what about the original data, the real data that are used to generate the synthetic data at the end of the day, from the model and the synthetic data. What do you do with them? Yeah, thank you.
I can quickly talk to that. So I think obviously that would depend on the use case, and I think on the type of original data. So in some cases, as I mentioned, the original data might be explicitly collected or donated, and we want to use it for even evaluating the synthetic models or the synthetic data generation process. And so I think it does depend on the sensitivity of the original data and why it was collected. And but most generally, once we have a generative model, we don't need the original data anymore. So there, we could delete it and then just rely on the synthetic data for downstream model training.
Omar, any thoughts on this, on your business model? If you want, you can elaborate a bit, looking at your business model, at your services. Yes.
Yeah, definitely. I think what Florian mentioned is covers most of the answer. It really depends on the case, and it really depends on what the data was collected for what purposes, and so on. Well, one thing where you would like to still keep the original data is for primary use cases that do require that original data. For example, you have your business flows and processes that do require the original data, and you want to keep the original data for that use. But if you want to use for testing or developing machine learning models, then you don't want to use that original data, and you would like to use the synthetic data. So those use cases are slightly separate, and it's not because you have a synthetic data then you will just completely get rid of the original one, because you actually would like to still keep on using the original one for their primary users.
Yeah, I think here the issue is very, you have the issues of the primary use, for which you have this original data, and the possibility in certain use cases also to share the data in a form that which is not, which is transformed. Now let's decide. I don't go for the assessment whether it is anonymized or not. That's not my task here. But I mean, that are supposed to be anonymized in any case through the data synthesis and reused, for other kinds of uses. And here also the legal aspects might come. But here, for example, what do you think? For example, under this point, we are going a bit towards the next panel. But I mean, do you consider, the other question is for both of you, that transferring generative models, or letting others use generative models, does not entail personal data processing? What's your feeling about that? Do you consider still their personal data, what is coming out? So, which then entails all compliance questions, issues there. What's your position on that? I mean, this is just your thoughts. That's not an assessment. As a data protection authority, we are a data protection authority for European institutions. We are not competent on you, so feel free to say what's your thoughts or what your considerations are. Thanks.
I can start briefly. So I think it was also mentioned in one of the previous talks, the use of the general models or the use of the synthetic data produced based on the generative models, in my opinion, are still subject to the same risk assessment that any data use must be subject to. It's not because it's in a model that somehow it makes it out of any risk assessment. The model is what generates the data. So if the data generated by the model is itself subject to this, there is, in my opinion, no valid reason why that model itself should not be subject to the same constraints. Of course, there are levels of indirection, and there are things like control mechanisms that you can apply on this, and that are different from a complete release of the data, and this is true. So you can curate what things you allow to others to ask your model or others to do with your model, and this might provide you some extra level of control and maybe extra level of guarantees, but it doesn't change the fundamental equation here, I would say.
Thank you. Florian, any thoughts on that?
I'm not sure I entirely got the question, but I think...
Yeah, I can repeat a bit. I mean, the thing is that, you have real data, which are personal data. And then you have, these models who are created. And then you have synthetic data that you might want to use instead of personal data for doing something. For example, you do in your computer vision or creating simulators or something like this. So the question is, how do you feel about that? Where are we? Are we still in the, when you, for example, there are people that share data, there are other models where you share the generator or somehow, or you provide a service where you can generate data. So, I mean, do you think that providing this service is still a sort of, producing, I would say, some sort of personal data that might be under the applicable legislation? Now, of course, the legislation that considers PII or in Europe personal data based on GDPR as something subject to the law.
Right. So I'm not a lawyer, so I can't answer the legal question.
Yeah, of course. But, I see.
I think I had some pointers in my slide. So there's like one nice thing with differential privacy is that if the model is trained in a differential private manner, then because of the post-processing and composability guarantees, the generated data is also differential private or has the same guarantees. So if the data, so the model which comes before the synthetic data has those same guarantees. So I don't see any reasons why that generative model should be restricted more than the actual data. And I think there was a second part to your question, and I could imagine that there are services. I mean, there are some services that already generate images. I think the important question is how were those generative models trained, and really making sure that they follow the best practices, and maybe even, as we discussed earlier, that there are ways to evaluate those guarantees outside of just relying on the theoretical guarantees, and yeah, really having a way to check that best practices were followed. I think that would be important.
May I add something, a personal consideration on that? I had the impression also from other, remarks made elsewhere, that there might be a difference in, if you provide a service where a controlled service, for example, I think that Khaled was talking about that, a controlled service where people can inquire, I would say, your model, but the model is on your side, is protected, is in a protected environment, controlled environment, where you can even give licenses, I would say, and this happens, sort of, sandboxes or whatever you want to call them. So where you regulate the way that people can interact with your model, what they do with, why they do it, so forth and so on. And then differently, the fact that the model is transferred to someone else, because I think also in terms of possible attacks that you could do when you have completed at your disposal the model that you have in terms of the two kinds of linkage and attribute inference attacks, it could be a different situation. Any comments on that from Omar and Florian, if you so wish?
Yeah, I can have a quick comment. So there's definitely a distinction between the type of attacks that are possible if someone has a model. Generally, it's called like white box versus black box attack. If someone wants to try to invert or reverse some of the model outputs, and they can look at the model weights if we're talking about deep learning models. So that definitely is I think, a consideration. And yeah, that's why it's even more important to really know how this model was trained. If let's say if it was trained with sequential privacy, then those guarantees hold independent of if someone has a model or not. But there might be other implications if someone can really look at the model weights and extract weights and to try to invert the model output.
Omar, do you have any thoughts on this?
Nothing to add. I think Florian summed it very, very nicely.
Listen, with this, I thank you so much. We are at the end of our session. So thank you for your contribution, and we hope we can further this discussion because there is a lot of expectations from all sides, I would say, from your side, from our side. I mean, also from the side of regulators, we are regulators, but I mean, and also from others. I mean, there are a lot of opportunities. At the same time, there is a lot of prudence that we need to keep to understand. But I think that, several steps are needed because that's we need to understand more all and take, some certainties. We will see. We will see what comes out. So, but for the time being, thank you so much to both of you. And this is the end of the practitioner session. So we have now a final shorter session, which is a legal one or policy one, where I have my colleague, Anna Kollaps, who will moderate and introduce the participants. So Anna, if you are with us, we can swap. I can give you the floor.
Hello, Massimo, do you hear me?
Yes, of course. I see you and I hear you. So I give you my virtual, let's say, floor. And the floor is yours now. You can introduce your speakers. Thank you, Anna.
Thank you, Massimo. Very happy to take this virtual floor. from you. So hello, everyone. Greetings from super warm Brussels today. Welcome to the panel, Synthetic Data as a Privacy Enhancing Technology and the GDPR. My name is Anna Kolabs. I work as a member of the cabinet of the supervisor at the EDPS, and I'll be the moderator of this panel. Very happy to. Thank you also from my side to my colleagues of the technology and privacy team for having organized such a very interesting and crucial webinar today. So this panel features Dara Hallinan and Kelsey Finch as our speakers. While introduced in a second, perhaps just briefly, I think one of the main questions that this panel will try to aim is to address is to which extent synthetic data might still involve personal data in the legal meaning of the GDPR. Could one still establish a correlation between the generated data and the original training data set that could lead to identify individuals? So we heard from the supervisor earlier today, there is an heavy interest these days in synthetic data, and not without justification. If synthetic data proves to be anonymous data, then one could argue that we're outside the data protection realm, we're outside the data protection framework, and we know that there is much appetite for that. But if on the contrary, is in fact not proven that synthetic data is proper anonymous data, then we have a need to reconcile it fully with GDPR, and not only the process, but also the outcome of this data synthesis. So what are the risks in this? Where are the opportunities? I think that this question are still very under discussion, and they represent the crucial ones around which the whole legal and policy debate is revolving around now. So that's why our panel will tackle today the policy and legal aspects of synthetic data, especially under the umbrella of the GDPR. So without further ado, let me present you our first speaker, Dara Hallinan. Dara is a legal academic working at FIS Karlsruhe. A specific focus is on interaction between law, new technologies, between law, new technologies, particularly ICT and biotech and society. He studied law in the UK and Germany, completed a master in human rights and democracy in Italy and Estonia, and Dara wrote his PhD at the Vrije Universiteit Brussels in Belgium. He's also program director for the annual Computers, Privacy and Data Protection Conference, editor of the bi-weekly Data Protection Insider, an author of the OUP book, Protecting Genetic Privacy in Biobanking Through Data Protection Law. So Dara, the floor is yours for your remarks, please.
Okay, can you hear me? Perfect. Okay, so you highlighted that the key question was whether synthetic data constituted anonymous data. Of course, this is really the key question. But what I want to do actually with these remarks is to do something slightly different. I want to highlight the approach to the categorization and dealing with data synthesis technologies and synthetic data, which I think is superficially going to seem very appealing to the data protection community, but I think we actually might do rather well to avoid. When I hear about data synthesis and synthetic data in relation to data protection law, in those rare cases when I do hear anything about it, I often hear it being discussed in terms of anonymity or in terms of anonymization technologies as they're traditionally understood. I think, however, that the data produced via synthesis are likely to display characteristics which differentiate them considerably from data produced via other forms of anonymization technology. And in this regard, to deal with synthetic data or data synthesis technology simply as just another form of anonymous data or just another form of anonymity technology is going to produce rather misleading or at the very least incomplete conclusions. I would suggest that rather than looking at data synthesis technologies as anonymization technologies, I wonder if it doesn't make more sense to consider these technologies as something like simulation technologies, which merely can, in certain cases, function in the capacity of producing legally anonymized data. And I'm going to provide two examples of issues which I think would largely be missed if we consider data synthesis technologies and synthetic data solely in terms of anonymity and in terms of anonymization technologies. So first, when we talk about anonymization technologies, what we're usually discussing is the ability for a technology to remove or obfuscate identifiers in a data set such that the set is no longer connected or no connection can be made to an identifiable individual. It's very clear. And this often implies that the original data set needs to be deleted. Otherwise, the original data likely provides a key to the identifying information in the anonymized data. So in brief, you can either have anonymized data or personal data, but not, or at least rarely and almost never discussed in the legal context, both at the same time. With synthetic data created from an original set of statistical properties, however, there's not necessarily a clear relationship between any data record in the synthetic set and a specific identifiable person. And this raises the relatively novel question, for data protection lawyers at least, as to whether data synthesis technologies then facilitate the possibility to create a legitimately anonymous data set, potentially many legitimate anonymous data sets, whilst also retaining the originally identifiable data. And that raises a series of further questions. So for example, what does this mean for our concepts of identifiability, pseudonymization, anonymization, et cetera, and all the related contexts? And what specific options and risks does this possibility pose to data subjects? You don't grasp those kind of questions looking at synthetic data and synthetic technologies just in terms of anonymization and anonymization technologies as traditional. Second, when we talk of anonymization technologies, what we're usually concerned with is the scope of applicability of data protection law. Does the technology in a given context exclude a classification of personal data or not? We're seldom interested in the significance of the specifics of the anonymization technology in relation to the applicability of the whole swathe of the rest of the substantive provisions of data protection law. So in that regard, actually, we generally work from the assumption that once personal data is identifiable, with some small set of differentiating criteria concerning sensitivity and concerning the semantic content of the data, actually all forms of data largely have the same core characteristics and are amenable to regulation through all the same principles of data protection law. And actually, I'd argue that the principles of data protection law were designed around and to regulate only a very specific conceptualization of data. And that's semantic data in the form of facts about individuals stored in man-made media, accessible to human understanding and adaptation. So this raises the question as to whether the principles of data protection law will function effectively in relation to synthetic data, which haven't been fully anonymized, either by design or by re-identification, or which nevertheless constitute the subject of data protection law by some other criteria. So for example, if they're used in an automated decision-making process about an individual. There's no guarantee, just prima facie, that this relatively new form of data creation is going to create data and use context which fit nicely and neatly within the concept of data that we've had up to now, or that the data protection law, as I see it, is really built around. And a number of interesting questions are raised in this regard. How, for example, should the accuracy obligation be understood? How should it be realized in relation to synthetic data? Or how, when processing is based on synthetic data as the basis for a decision impacting an individual, how should we conceptualize transparency obligations? What does an individual need to know about synthetic data, about the processes that produce synthetic data, such that they understand what this stuff is and its potential impact on them? Are we going to have another version of the discussions which happened around algorithmic transparency? Or are they going to take a completely different form? So all of the above has highlighted that synthetic data and data synthesis technologies differ in important ways, I think, from anonymous data and anonymization technologies as we've traditionally understand them. And there's a risk in just looking at data synthesis technologies and synthetic data in terms of anonymity and in terms of anonymization technologies. I further highlighted that there are a number of interesting questions that synthetic data seems to pose for data protection law, the provisions of data protection law. So the question that then pops up is, well, how might we actually go about looking for sort of answers as to how these specific qualities of synthetic data might be considered and addressed in data protection law? So I think in the first instance, it's relatively clear we're not in the realm of a hugely dangerous technology, or at least currently. I mean, quite the opposite. So we're not looking for preemptive bans. What we're actually really looking for is a regulatory approach which steers development to maximize the potential and mitigate the risks involved with the technologies. And in this regard, there's not really any ex-ante one-size-fits-all approach that we're looking for. Now, unfortunately, for stability and certainty, technological futures aren't quite as determinant as we might like to, or we might hope them to be, and the actual problems and opportunities presented by the use of synthetic data is going to depend on the context they're created in, the context they're used in, and the other technologies they combine with, and the sort of socio-technological possibilities they eventually create. In relation to specific contexts then, in relation to these specifics of the possibilities they create, how can we then identify problems and opportunities and ways to shape regulatory responses, at least given that legislative intervention doesn't seem very likely at the moment? Well, one option is obviously to engage in really traditional legal analysis of the derivation of knowledge from the parsing of legal texts. And this is certainly going to be very important and reveal important knowledge, but it's very unlikely to provide very definitive answers. This is not only because there are a number of ways in which technological development present novel possibilities which existing legal systems are simply unsuited to deal with, or in relation to which legal analysis is really going to provide very limited or unsatisfactory answers. If anybody's really interested in frameworks for this, Liria Moses has a fantastic article on this. I think it's freely available on SSRN. Equally, sort of legal analysis, traditional legal analysis, depends on the predictability of the nodes of regulation through courts, for example, and the kinds of outcomes they're going to come out with. In relation to key concepts relating to synthetic data, so for example, anonymity, courts have been relatively random in some of the things they've said, which makes this legal analysis awkward to sort of project into the future with any certainty. So for example, in Breyer, for the first time, the CJEU came out with this idea that that legal restrictions could serve to produce anonymous data. It's the first time it's ever been used, and I haven't seen it anywhere in data protection scholarship or law since then. A relatively random appearance, sort of a appearance of a legal fact to my mind. So another option is going to be to engage in more organic approaches. So for example, stakeholder engagement, and through these more organic approaches to produce guidance by authoritative bodies, which then can be looked at as reference points for actors involved. This is certainly going to produce some answers, and it seems very much this is the preferred direction of travel in the development of data protection, and very sensibly so, I think. However, and not solely relevant for synthetic data, this approach raises really a lot of questions which I think we haven't really got properly to grips with yet, and we haven't really started to answer yet. And these questions concern the degree to which the use of such organic guidance and the creation of such organic guidance can actually legitimately build legally relevant information and can legitimately integrate into existing legal systems. Julie Cohen, in her book Between Truth and Power, has a fantastic chapter on the problems that arise around this when she discusses internet governance. Just some of the questions that pop up to my mind in this regard. So how, for example, should such guidance actually be categorized and recognized? So for example, EDPB or EDPS guidance as normal administrative guidance as we might usually understand it, or actually, and this seems intuitively more correct, some novel form of jurisprudence, the thing we look to understand the law. If we are going to take the second definition, under what procedural conditions should the production of this knowledge actually then be regarded as legitimate? What are the kind of information flows in and out of the EDPBS or EDPS, sorry, and how should we understand them such that we restrict those illegitimate flows and permit those legitimate flows? In relation to court decisions, there are reams of provisions and guidances and regulations concerning exactly what is and isn't permitted procedurally to create a decision. I don't think we have those yet in relation to these administrative bodies that are so key to the creation of law in the data protection space and will be so key to the creation of law around synthetic data. So, thank you.
Thank you very much, Dara, for this excellent contribution. Thank you very, very much. I'd like to just take this opportunity to remind the audience that the public chat functionality can be used to throw questions already at this stage. Then those will be filtered to me and I will post to our speakers. Dara, maybe a follow-up, very flash thing. Do I understand correctly? Are you suggesting that we are the product of the data synthesis will be, in any case, out of the dichotomy personal, non-personal, as we know it in the GDPR? Maybe just a yes or no, maybe, because
yes, that's an unfair question to ask in terms of yes or no. Potentially in some cases, but each case will of course have to be looked at specifically. I think that the thing you're referring to in my discussion is the idea that you might be able to create an anonymous and an identifiable set at the same time. So if you're looking at whether data is anonymous or not, you actually look at the data itself, and then you look at the other data sort of surrounding it, and you see if you can make connections such that you can identify an individual. Normally in anonymous data, or the anonymization of data, if you have the original set, that contains the key to seeing, to identifying the anonymous set as well. In synthetic data, however, if you have the synthetic set, as far as I understand, and I would suggest that perhaps some of those who are technically more capable than I might intervene if I'm wrong, is that you can create records which reflect statistical properties of the original set, but actually don't necessarily relate themselves to any specific individual. So if you took the synthetic set, even if you had the original identifiable set, you wouldn't be able necessarily to make a link one-to-one, one record to one record. Of course, that will be context dependent. It will depend on how the set is created, what it's being used for, etc., etc. But the possibility is there, and the possibility. Okay. Sorry.
Thank you, Dara. Definitely not a yes or no answer. You're right. Let me introduce you to our next speaker, dear audience, Kelsey Finch. Kelsey is Senior Counsel at the Future of Privacy Forum. She leads the FPF's projects on data de-identification, ethical data sharing as smart cities and communities. Hello, Kelsey. Her work has been published in the Cambridge Handbook of Consumer Privacy, the Fordham Urban Law Journal, and the Santa Clara Law Review. Before coming to FPF, Kelsey was an inaugural Westin Fellow at the International Association of Privacy Internationals. She's a graduate of Smith College and Benjamin Cardozo School of Law with a concentration on intellectual property and information law. Kelsey, we very much look forward to hearing from you. Please, the floor is yours.
Thank you so much, Anna, and thank you everyone for the kind invitation today and for a really, really fantastic discussion. Really excited to contribute my little part of it. I also want to start off just by heartily agreeing with everything that we've heard from Dara. I think this does raise a really interesting sort of existential crisis for data protection law and what we're trying to protect. And I think really is pushing the bounds of what inferential disclosure might look like and what we care about from the privacy and data protection perspective for individuals and for groups. I also really strongly agree with this idea that we're going to need to track real-world uses and consequences to understand the evolution of synthetic data. So for my part today, I'd like to speak a little bit to the pragmatic, on-the-ground perspective of synthetic data and the potential policy and compliance considerations that I think we're going to need to address before synthetic data can become a more regular tool in our toolbox. However promising synthetic data is in theory, we do know that it will require extremely careful and thoughtful implementation to reach that full potential in practice. So first off, just want to, echo Dara in recognizing, and everyone else, I think, actually, in recognizing we are quite early in our overall understanding of synthetic data's position within our legal frameworks. On the one hand, I think this means that this is a very good time to be having these sorts of educational discussions. On the other hand, it does mean that there is a fair amount of inherent uncertainty as to how things are going to play out and how some of these questions will be answered. I think already there is a range that we're seeing of differing opinions among legal scholars about the extent to which synthetic data will or will not be considered personal data. I think most agree that it will depend on the circumstances surrounding the generation use of the synthetic data, and that there is quite likely to be some variation potentially between global laws. I think, candidly, I sort of expect that this uncertainty will remain unresolved until we get additional guidance and interpretation and enforcement, all of which will, of course, just take some time. So I think, fortunately, we are in a moment where authorities are actively reconsidering the role of privacy-enhancing technologies. Whether those will have or should have the force of law is a really great and interesting question. But right now, good to remember that we are eagerly all awaiting an update to the Article 29 Working Party's opinion on anonymization, originally published in 2014, and hopefully that might shed some light on synthetic data's role under the GDPR. In the interest of interoperability, I think we're also expecting new guidance or updated guidance on anonymization techniques and standards from authorities in the United States, in the United Kingdom, and Canada, as well as in emerging and updated legislation in places like Brazil and South Korea, Japan, Singapore, Russia, India, China, and nations all around the world. So this is a very active field of discussion and potentially emerging or updated guidance for us to look to. The next thing that I'd like to emphasize is just how important it is for organizations and policymakers to be very clear about what they mean when they say synthetic data. As we've heard today, synthetic data can be generated in many different ways, and different methods might carry different implications for the data's utility and for privacy protection and data protection obligations. So one of the key things, for example, that's going to be important to distinguish is between those data sets that are fully synthetic, where there is no one-to-one correspondence or mapping between the source data and the synthetic data, and those that are partially synthetic or a hybrid model. And I think probably will expect higher privacy and data protection risks and compliance obligations in situations where organizations are enriching or augmenting their synthetic data with some of that source data for whatever reason. Also going to be important for organizations to distinguish between more vanilla synthetic data, which doesn't undergo any form of data standardization sort of during or after the training, and synthetic data that uses formal methods like differential privacy or anything and everything in between. I think the risk of re-identification between any two synthetic data sets might be sufficiently different based in context and practice that one might fall within the scope of GDPR and another not. I think it's going to be really critical for policymakers to clearly define those parameters for what's considered personal data, and for organizations to be transparent in how they generate and validate their synthetic data, and to not just assume that all forms of data synthesis are equivalent or equally protective. Because of course, at the end of the day, what really is going to matter is how these models are implemented and how effectively they're implemented. It might be that you have, in ideal conditions, created something that is truly non-personal anonymous information, but small errors in the process or misconceptions might change that calculus. As part of that, I think, as we've heard over and over today, organizations and policymakers need to remember that there is a non-zero privacy risk for synthetic data. In many cases, it's likely not a silver bullet solution to this desire to share and use data in new ways. It doesn't automatically resolve that tension between the analytic utility of the data set and the amount of privacy protection it gives. And that there is always this chance for small bugs to make their way into the process, or for the synthetic data to be used in unexpected ways. I think also some interesting challenges that I've definitely seen folks engage with in the chat throughout today as well, about synthetic data raising unique transparency challenges, particularly due to the complexity of the manner in which it's created. Very difficult to convey the ways in which sophisticated models are, adapting or building off of the source data. So there is a risk, I think, that's particularly acute of false re-identification, which we'll have to deal with, right? So if an individual appears to be identifiable within a fully synthetic data set, even if they're not actually present, it might be really difficult for the organization to prove that that's not the case. This is something I know Florian engaged with earlier. And there might be ways around that, right? Organizations can include very clear warnings or labels or notices about the synthetic nature of the data. They might use conspicuously non-natural identifiers in their training data. There might be other approaches, but this is something that will require some proactive work and thinking. And I think that this is something that organizations can't underestimate the potential for this to create perceived privacy risks and perceived harms in some of the ways that we've seen, have created struggle with traditional anonymization techniques as well. And so just finally to want to highlight some of the compliance obligations that will likely accompany synthetic data, and for help organizations make sure that they're not going to underestimate the time and attention that they'll need to invest in the appropriate technical and legal and operational documentation that's going to come along with using emerging technologies like synthetic data. It is an important task to be the folks who help move the ball forward on this and help pave the road for more robust use of synthetic data, but it will take some time to make that process a little bit smoother and a little less friction during that. So, and I think actually Dara raised a really interesting point about whether the current data protection frameworks are in fact a good fit for synthetic data at all. I think until we resolve that question, however, organizations should expect to live with the current obligations under the GDPR. So I think two key things that we've talked about today and we've seen in the chat is that organizations really do have to remember that there are two key phases for synthetic data from a compliance perspective. So the first is that process of creating the synthetic data, which does involve processing personal data and requires full compliance with the GDPR. I think that's not in question. The interesting thing then is that synthetic data output, which might be non-personal if you've done it correctly and you've done it in a way that mitigates privacy risks. But this might be a situation where organizations still have some level of accountability or other sorts of controls in place to validate that they have done it in a really effective way. So, looking at some of the things that organizations are going to have to keep in mind for compliance, the process of many of these obligations are familiar, the things that organizations have to do for other data every day. However, the process of synthesizing data is particularly complex. And I think organizations need to appreciate the challenge of capturing it in a way that is appropriate for lay audiences, for data protection officers, for data protection authorities, and for other policymakers and stakeholders. So part of this will be, one, being prepared to clearly articulate in appropriate depth and detail how you create and how you use synthetic data, and doing so in a way that's appropriate for a public transparency notice, perhaps, for a data protection impact assessment, as part of a data processor agreement, other sort of key documentation. Part of this is dealing with that black box transparency and accountability challenge that we see for other sophisticated algorithmic and machine learning systems. Questions around explainability, questions around the impact of potential bias, and of course, the sort of looming specter of the proposed European AI regulation. Not entirely sure how any of that will play out. All things for organizations to be thinking about in their use of synthetic data. There are going to need to be controls to appropriately sequester the source data from the synthetic data in some ways to avoid commingling them, where one organization is doing the entirety of the process. As we've heard, sort of a best practice is likely to continue to be to conduct privacy risk assessments or evaluations to evaluate residual privacy risk in, and sort of through the synthesis process. I think really important for organizations not to underestimate is the need to have appropriate personnel on hand to orchestrate all of this I think it's actually going to be far easier to hire or train somebody to do the technical work of synthesizing the data than to find leaders and staff with the sophistication to really understand when and how and for what purposes to generate and to use synthetic data, and to do so in a way that respects the organization's legal and ethical obligations. I think there's going to be a learning curve that we're all going through in this process. And then finally, just want to emphasize as well that there is likely to be a scalability challenge that we have to face before synthetic data becomes a really widely used data protection tool. So small and medium-sized organizations are going to have to deal with perhaps being technically grown enough to access or use synthetic data, maybe before they're really mature enough to go through this full data protection compliance process. I think also likely that we're going to need domain-specific guidance to help organizations really achieve that appropriate balance between analytic precision and privacy protection in their activities, so that we can really use synthetic data to its full potential. So just because I've been talking for a while, I'm going to turn this back over before we're completely gone. Just want to say that synthetic data is a very promising next step in our quest to optimize the analytic utility of large data sets while avoiding inappropriate disclosures of personal data. I don't think it's the holy grail, but I do think it is worthy of much more attention and investment by organizations and policymakers. And I'm quite optimistic for the progress that it represents. All right, thanks, Anna. Happy to hand it back to you.
Thank you very much, Kelsey. Thank you very much, and especially from my side to have put some emphasis on the variation of synthetic data and also on the compliance aspects when it comes to the process of synthesizing and using synthetic data. I have a question for you both, and actually feel free to pick it up and to answer if you feel like. Decision from an accountability standpoint, decision based on synthetic data might have legal repercussions. Do you think there is a risk that these decisions might be legally challenged? Anyone who is willing to take this one?
Sorry, Anna, could you repeat the question?
Can't hear me. Now you can hear me, right? Yes. So from an accountability standpoint, decision based on synthetic data might have legal repercussions. For instance, those made by a national health authority. The question goes, do you think there is a risk that this decision might be legally challenged? So decision based on synthetic data.
Kelsey, would you like, or shall I?
If you want to jump in, I think hard to sort of predict the future in this one, but if you've got a crystal ball, I would love to.
I do, but I'm not showing it to anybody because it doesn't work very well. So basically, yes, of course, the use of synthetic data is just one means to achieve an end, and it's the end that causes the legal repercussions. In that regard, if the legal repercussions are challengeable under applicable law, the use of synthetic data to that effect can also be challengeable under applicable law, provided that is the cause of the issue. I'm not sure. I wouldn't see that as anything specific to synthetic data. If synthetic data is the cause of the issue of challenge, then of course it can be challenged, provided a challenge is available. If not, then no. But of course, it will depend on the context.
Yeah, and just to highlight that, I think that part of it, I think that answering the question from a purely legal perspective is something that we can accomplish, right? We can look to the existing bodies of law. Somebody will be able to make a decision about this, but the challenge of understanding and addressing and trying to pierce that veil of what's happening in generated data is going to be, I think, a bigger source of angst from a public perception and sort of process perspective than a sort of a purely legal question. So it does seem like it's likely to come up. I'm not sure if synthetic data will be the first place that it does, but I think it's something that organizations should not assume is impossible to happen. No.
Thank you both. maybe let me be just more provocative from my side. Do you think that there might be an implicit incentive in the market to bypass through synthetic data GDPR obligations? And if this implicit incentive exists, of course, I would be worried. I think we should be worried, but then should we worry about this implicit incentive, assuming it exists, of course? So this is a question for you both.
So I'll just say that I think that that is certainly something that folks have been concerned about for the entire scope of the anonymization techniques and privacy enhancing technologies generally, right, is that this is seen as an end run around or a way to bypass legal obligations. I think it's a difficult one. I think that if folks are looking at it in that way, they are underestimating the challenge that they're putting themselves to. I do think that it's important for folks to appreciate the complexity of the task of generating truly synthetic data, and that probably walking through that cycle will create additional sorts of safeguards and controls. And it's not the sort of thing that you can do, in a vacuum. There will be other organizational requirements and partners that you're going to be engaging with. You're doing this for a particular reason. You're trying to achieve a very careful balance of utility and privacy protection. So I think the idea of using synthetic data has baked into it a recognition of privacy risk and a desire to address privacy risk. It's a question of how many resources you can apply to it. I think that there is a concern, though, about this perception, and that it behooves organizations to be very transparent and be very accountable. And so perhaps, even if you aren't fully, even if you aren't governed by the GDPR, to go through the process of, being transparent about any kind of data protection impact assessments that you've conducted or any other kinds of safeguards or controls that you might have in place. Maybe still have a data use agreement, limiting the uses of that data to things that feel most appropriate depending on the circumstances. Approaches like that.
I say, well, look, it's going to be context dependent again. If you're talking about market incentives exist where there is a surplus to be generated through the use of some kind of means to produce something that people want. So if it is cheaper to avoid the law and use synthetic data technologies as opposed to other anonymization technologies, then you have a market incentive. And that will for sure exist in certain places. And I think you've already seen that. There are certain sort of certain narratives around synthetic data that already sort of point to this utility. We should both be positive about that and concerned. The use of big data sets is not all bad. And the idea that we can remove certain privacy risks, or actually I'm not going to say privacy risk, certain risks through the use of personal data by anonymization is not something that we should always be terrified by. In certain cases, that's really good. And it facilitates innovation. It facilitates uses of data sets for means and for purposes that they wouldn't otherwise have been used for, that we want to push forward. So scientific research, for example, we want that. This is a good thing. Having said that, in a true political economy perspective, essentially what you have is a dropping of mandated protections that are designed to serve certain underlying aims, and the ability to go around those by this novel technological possibility. And in the cases where the values that we want to protect remain at risk despite the use of synthetic data, then the fact that this is a market viable solution and that the market creates an incentive, then it's a problem. So for example, if people are using synthetic data, and I don't even need to talk about privacy risks at the moment, I'm going to talk about something else, to avoid sort of obligations under something like the Nagoya Protocol regarding genetic ownership or ownership of genetic substances, that's a problem. Equally, if data giants are using synthetic data to come up with new ways to profile, et cetera, based on sort of synthetic group profiles that cause risks that we would otherwise like to restrict, but actually fall somehow outside the GDPR for whatever reason, then it's a reason for concern. But again, the contexts are so important in this discussion when you have a very, very abstract top-level concept of what a technology is and its variations, and an abstract top-level concept as to how this will interact with the data processing ecostructure, our ecosystem, and the legal ecosystem that we've hammered onto that that processing ecosystem, such that we can regulate its interactions. Yeah, I always find sort of when I give these answers, it must be incredibly unedifying for anybody listening, but fortunately we are only that far in the discussions thus far.
Thank you, Dara. Thank you very much. I have time just for one last question, but I'd like to ask you to please keep your response, if possible, short. In the hypothesis that regulators accept synthetic data as an anonymization technique in principle, what kind of accountability elements you might expect regulators to consider necessary? Any link to the current AI EU regulation proposed safeguards? Who would like to take this one?
You know, I think that just to say that we are quite, even earlier in the process of understanding the proposed AI regulations, I think that too far to really to really think about or appreciate or build towards specific accountability measures. I think important to recognize some of those explainability, some of those transparency, some of those quality control and validation procedures that are being built into that, though, and to look at what the concerns are, right? The concerns that are driving the accountability will be around potential privacy risk, but also, as you know, the potential utility of these data, of these algorithmic systems, and what they're going to have for real world consequences, the ability to sort of pierce that veil and understand how decisions are made and potential long-term impacts and bias. I think all of that will need to be considered and addressed in some way.
I don't have much to add to what Kelsey said, which I completely agree with, apart from the fact that maybe we should all avoid putting too much pressure and hope on this AI regulation. The first draft is out, and if anybody's been following e-privacy for the past years, we can see that e-regulatory process is neither slow nor predictable. So yeah, also the AI regulation only applies to certain types of AI in certain contexts. So presumptions that it's going to do this, or, you know, if we look to it for that, for this guideline or this guideline, should be taken with a pinch of salt, or should be put out with a pinch of salt.
Thank you very much, Dara. I'd like to thank you both, Dara and Kelsey, for the excellent contributions. I enjoy very much this moment, and so I'm sure the audience. So it's time to conclude this session, this excellent panel, and it's time to pass on the virtual floor to my colleague, Thomas Zertig, for the concluding session.
Thank you, Anna.
Thank you. Bye.
Thank you both, and thank you, Anna, for the moderation of the last session. Dear all, I'd like to come to a close of today's IPEN webinar. And first, my big first thanks go to you. We were at times 170 participants today, so stellar. Thanks for staying with us and for not watching the Euro 2020 football games. I've seen you've been extremely active in the chat. Thank you for all these exchanges, and I hope you enjoyed what we have heard today from our impressive and very interesting speakers on what are actually very practical insights on synthetic data usages today. So before I come to a small summary of what we heard today, I'd like to remind you that this IPEN webinar takes place before the ENISA Annual Privacy Forum, and so if you're hungry for more on privacy enhancing technologies and data protection issues, then please go to their website, register. The registration is still open for the Annual Privacy Forum. You will find a link on the EDPS IPEN website. So what have we heard today? Stephen explained us his process for synthesis and pseudonymization. And I think he ended with a very clear call to a lot of people, including data protection supervisory authorities, on future guidance. And I will come back to that at the end. Khaled gave us, I think, a very, very comprehensive tutorial on all possible aspects of synthetic data. I think that was very, very useful. And Florian, he shared his approach to what he is doing at Google on enhancing privacy, including on his use on synthetic data. Then we've heard from Omar from the business perspective, his experience with day-to-day creation of synthetic data. And then we turned to the more legal aspects with Dara, who pointed out, I think rightly, that we're not talking about a hugely dangerous technology, but who had a lot of legal questions to explore. As did Kelsey, who rightly pointed out there is much more work to do. We are not there yet. And she threw in the magic word in data protection, at least from the point of view of a data protection supervisory authority, accountability. So again, thanks to all the speakers for their time and for their willingness to share their expertise with us. Just a quick assessment of where we are now on synthetic data. I've heard a lot today. There is a lot of information we have to digest, technical and legal, so lots to chew on. But I think, again, as I guess in most of the cases in data protection, no black and white. We have heard about risk assessment, privacy risk minimization, and case-by-case assessments. That's clearly the case. For me, I think the main takeaway is that I can very much see the added value of a future guidance on this topic from the EDPS or even the EDPB to look at synthetic data. Certainly, IPEN will look at this and try to follow up this topic. So, before we all leave, I would like to say a very big thanks to the EDPS IPEN team, Massimo Attoresi, Anna Kollaps, Vitor Bernardo, Karim Skayer, and Alexandre Lea. Without their help and their passion for technology and data protection questions, we wouldn't have had this great IPEN webinar today. So big thanks and shout out to them. If you want to learn more about IPEN, please go to the EDPS IPEN website. In the coming days, you will find there the recordings of today's webinar and the presentation. If you want to be kept up to date on our activities, please go and register to the mailing list for updates. And I hope to see a lot of you soon in our next IPEN webinar, date and place to be announced. Now, I warmly invite you to stay on in this very room for an informal chat and exchange of views. There will be no recording, and please gather and feel free. And if I don't see you there, then hope to see you again in another IPEN webinar. Maybe I see you tomorrow in the APF event. And until then, thank you very much and see you then. Bye-bye.